Welcome to the Programming with Python course. Python is a versatile, high-level programming language available on multiple platforms. It's a language that's used by companies large and small to build a diverse range of applications. Areas that Python is used in include web development, data analytics, and business forecasting. The Python programming language syntax is very similar to English. It's intuitive and beginners will often quickly understand what's going on. It's also a great choice for experienced programmers who will appreciate its power and adaptability. Because Python is a very popular software development tool, it's important for you as a new developer to know how it works and to know how to code with it. This course covers the key points you need to know to begin programming in Python. Starting with Module 1, you'll get started with a Python programming language and associated foundational concepts. You'll learn to recognize common applications of Python, and you'll be able to explain foundational software engineering concepts, use operators to program output in Python, and use control flow and loops to solve a coding problem. And in Module 2, you'll build on what you've learned in the first module by learning about the core concepts that underpin the Python programming language, variables, and different data types in Python. And you'll get to use control flow and loops to execute code under specific conditions. This module also introduces you to working with functions and data structures in Python, recognizing errors, determining their causes, and deciding how to handle them, and creating, reading, and writing data in files. In Module 3, you'll learn about the programming paradigms of functional and object-oriented programming. You'll use functions to explore algorithmic thinking. Furthermore, you'll learn how to work with objects, classes, and methods in Python. Then you move on to dealing with modules, packages, libraries, and tools in Module 4. Here you'll learn how to find, import, and use popular Python modules and packages. Leverage powerful tools to optimize the programming workflow. You'll discover different types of testing and their features, and you'll be able to use testing tools to write a test. Module 5 is the graded assessment where you get to demonstrate your Python coding ability. You'll be able to exercise the skills and knowledge from this course, and you'll have the opportunity to reflect on the course content and the learning path that lies ahead of you. You may have encountered some concepts or terminology in this video that you don't fully understand. Don't worry about that right now. This course is designed to address all such issues and give you a solid coding foundation in Python. Enjoy the course.
The developer that wrote Python loved Monty Python's Flying Circus, a TV show. Instead of the snake, the python, he thought the name Python was short and cryptic, and he made it the language name. Hi, I'm Layla Rizvi. I am a backend software engineer on Instagram Calling in San Francisco. I've been coding in Python for 10 years. It was the first programming language I learned. I use Python every single day for my job at Meta. It's my favorite language to write in because it's so easy to use and simple. The first application I had to code in Python was to create a calculator. Since Python was the first language I learned, my first application in Python was a little tricky for me to build. Learning how to indent right, how to do spacing, learning the syntax, and learning what loops are, and all of these core computer science concepts was very hard for me. But I tried for a while and it worked out. Some important ways that you have interacted with Python in your day-to-day activities likely include using Instagram, using Facebook, using Google or Spotify. Python is such an ubiquitous language that you likely used it, regardless of whether or not you know you've used it. Python is also used for TensorFlow, which is a machine learning framework that Airbnb uses to classify images, and some healthcare companies use to classify MRI data. At Meta, Python is used for the Instagram backend. It is used for our ads, machine learning algorithms. It is also used for our production engineers who keep our services alive and running. You should go through the process of learning Python, even though it might be challenging, because it's an easier language to learn. It's simple. It has a lot of libraries that support it, so it also makes it easier to build more and more features because there's a lot of engineers that use it already. So it makes it easier to develop features quickly, and you can see results a lot faster with Python. Thanks for watching the video with us today, and good luck on your journey as a software engineer.
Computers and their programs are integrated into our lives at a scale we could not have imagined. Over the past 20 years, we have seen dramatic jumps in technological gains in areas of distributed computing, cloud computing, and AI improvements such as voice and face recognition and self-driving cars. In the next few minutes, let me give you a brief overview of the history of programming, and you will also learn the basics of how programming works. Computing dates quite far back in our history. Charles Babbage in 1822, while studying at Cambridge University in Britain, was working on bettering calculating devices such as navigation charts and astronomical tables, which at the time were used by many ships at sea. Babbage came to the realization that all these calculating devices contained various amounts of human error, and he wondered if there was a better solution. His solution was the difference engine. The difference engine used mechanical gears with numbers 0 to 9 etched onto their gaps, separated by gears' teeth. Its key function was to carry out one operation that was computed by manually moving hand cranks until the final answer was revealed. After building a working prototype, Babbage spent many years working on further improving his designs and constructing improved versions of the original idea. He created another device called the difference engine 2, but ultimately produced a new and better concept called the analytical engine. The analytical engine is widely accepted as being the basics of modern-day computing. Babbage's friend Ada Lovelace published a document describing how the analytical engine could perform a sequence of calculations, which is essentially what a computer program does. However, the analytical engine was never completed, and Babbage, like a lot of developers, did not invest in good documentation. With the historical side of things covered, let's now delve into understanding what programming is. Before I explain programming, it's helpful to understand how computers work at the most fundamental level. Computers only understand binary code, which consists of 2 digits, 0 and 1. This may seem quite strange at first, but with a little explanation, it will all make sense. 0 and 1 relate to different electrical states, similar to a light switch. 0 is equal to off, and 1 is equal to on. For example, in programming, when you calculate numbers, cost, or any arithmetic, you mostly use decimal numbers. Every program written needs to be converted to binary code or machine code. An example of decimal to binary conversion is decimal 1 is binary 1, decimal 2 is binary 1, 0, decimal 3 is binary 1, 1, and so on. A computer represents the binary code by using tiny electrical conductors called transistors. These transistors are housed inside the central processing unit, CPU, which is essentially the brain of the computer. When a program is written using any type of language, it needs to be compiled or interpreted. The outcome is to turn readable programming code, for us, into readable programming code for the computer. It's essentially extremely hard for humans to read and understand binary, and therefore, using it is error-prone. It's far easier for us to read and write programming languages. So, what is programming? Programming is the ability to provide a computer with a set of instructions in a particular language that it can understand and perform those operations or tasks. In other words, you need to tell the computer what you want it to do in a format and language it can understand. Programming is a skill. The more you practice and learn, the better you become. At first, it can take quite a while to write straightforward programs. As you progress, you'll become more familiar with the language and how the logic and conditions should be applied. Programming is also a creative skill. That's because you can write computer programs to solve problems in many different ways. And that brings us to the end of this video. You now know the brief history of programming and how typical computer programming works. Would you like to be able to program on different platforms, for example, Windows, Mac, and Linux, in an easy syntax similar to the English language? Then Python is your solution. It's a high-level programming language that works on many different platforms. By the end of this video, you'll know the benefits of learning Python and understand where to use Python. Python was created by Guido van Rossum and released in 1991. It was designed to be readable and takes a lot of similarities between the English language and mathematics. Since its release, it has gained greatly in popularity and supports a rich selection of frameworks and libraries. At present, It's currently one of the most popular programming languages to learn today. It's widely used in all areas of business, such as web development, artificial intelligence, machine learning, data analytics, and various different programming applications. Python is also very easy to learn and get started with. Given that the syntax resembles the English language, it makes it easier to read and decipher. Programs that are written in Python also require less code in comparison to programming languages such as C or Java. One of Python's key advantages is that it makes developers very productive and allows projects to be completed more quickly. Creating good software that is used by many is hard and very time-consuming. The simplistic nature of Python abstracts a lot of complexity away from the developer to allow them to focus on the task at hand. Given the language is quite easy to understand and pick up, it can be an easier route to market for new programmers starting out to get something produced in much less time. Compared to some other languages, Python has a much easier learning curve. It lends well to the philosophy of write less, do more. Now that you can describe the benefits of learning Python and where it can be used, it's also good to know that Python developers are in high demand. Becoming a Python developer makes for a good career choice.
When you start using Python, it's important to make sure that it works correctly on your operating system with your chosen Integrated Development Environment, or IDE. In this case, Visual Studio Code, or VS Code. So, an essential step in using this software is to make sure that the right version of Python is used as the interpreter when running VS Code. In this video, I will demonstrate how to set up VS Code on Windows and make sure that it points to the correct Python interpreter. So, I start by opening the VS Code editor. To do this, I click on the Windows icon in the taskbar, which brings up a menu. I then type Visual Studio Code in the search bar. The best match for the search is the Visual Studio Code app, which I click on to open. VS Code is now open. Next, I select Get Started with Python Development. This is a useful guide to setting up Python on the VS Code IDE. The first step in the guide is to install Python. I already have Python installed, and I can verify it by typing Python --version in the terminal. To open the terminal, select the Terminal tab on the top menu and choose New Terminal. After I press Enter, it displays Python version 3.10, which is correct. The second step in the guide is to create a Python file. I do this by clicking on the Create a Python File option in the guide menu, and then clicking on the Create Python File button that appears. Next, I put in a print statement by typing print hello world. I will explain what a print is at a later stage, but for now, you just need to know that it's for printing out a value within the terminal itself. Now I save this as a Python file in my root level directory by clicking on File, Save As, and then entering the file name helloworld.py. py is the file extension I have to use when saving a Python file. The next step in the guide is to select a Python interpreter, and I click on this option in the guide menu. And then I click on the Select Python Interpreter button that appears, which brings up all the versions of Python I have installed. I do this because I want to make sure that when I run the Python script, it will choose the correct interpreter. The version that comes up is Python version 3.10, and I set this as the interpreter because it is the most recent version. To test and verify that everything is working correctly, I have to run the Python file. In the top right of the screen, you'll notice a play button. I close the guide so that it displays better. The play button has a drop-down menu that has the option for running the Python file or running it in debug. I click on the Run Python File option. Note in the terminal window that it has run the file using Python 3.10 as the interpreter, and I get the output of hello world. And that means that I'm now set up to use Python directly in the IDE so I can run and debug my scripts. You now know how to create and save a Python file and how to select the correct Python interpreter to run your files in VS Code. When you start using Python, it's important to make sure that it works correctly on your operating system with your chosen Integrated Developer Environment, or IDE. In this case, Visual Studio Code, or VS Code. An essential step in using this software is to make sure that the right version of Python is used as the interpreter when running VS Code. In this video, I will demonstrate how to set up VS Code and make sure that it points to the correct Python interpreter. On my Mac, when I open Launchpad, I type in Visual, or VIS for short, and it opens VS Code. VS Code provides a walkthrough guide for setting up Python. This can be found on the welcome screen. However, if I don't see it in the main view, I can click on More, and then I click on Get Started with Python Development. It brings up the guide I can use to verify that I have everything set up correctly. Next, I check that Python is installed by opening the terminal window. I click on the bottom left of the screen and then on the Terminal tab. Then I type Python space dash dash and the word version. When I hit enter, notice that it returns Python version 3.10, which is correct. By default, Mac comes with Python version 2.7, but this is not the version I want to use. Instead, I want to use the most recent version. Next, I create a simple Python file. To do this, I click on Create Python File in the Get Started with Python Development guide. I put in a print statement by typing print hello world. I will explain what a print is at a later stage, but for now, you just need to know that it's for printing out a value within the terminal itself. Now, I save it by clicking on File, Save As, and then entering the file name, hello_world.py. py, or pi, is the file extension I have to use when saving a Python file. Now I have to check that I can run that file, and to do that, I need to set my Python interpreter. So, I go to the Get Started with Python Development guide again, and I click on Select Python Interpreter, which opens up the Python interpreter screen. Here I can choose which version to use from the drop-down menu. Notice that I have different versions of Python installed, but the one I want to use is the one I installed through Homebrew, and it is also the recommended one. To bring up the Python interpreter screen without the Get Started guide, I can press the Command key, Shift, and the letter P. Then, I type in Python, followed by a colon, and I choose Python Select Interpreter from the top of the menu. Then, I press Enter. When selecting the version of Python, it's best to choose the recommended one, but make sure that it's the latest version that you have installed on your operating system. Next, I'll run the file. First, I close the Get Started guide. Then, in the top right of the screen, you'll notice a play button with a drop-down menu, which has the option for running the Python file or running it in debug. I click on the Run Python File option, and then I click on the play button. Note that the output appears in the terminal. I have now validated that I have VS Code pointing to the correct Python version that I want to use, and that I am able to run and execute scripts directly on the IDE. You now know how to create and save a Python file and how to select the correct Python interpreter to run your files in VS Code.
Did you know that Python can be run directly in the command line on Windows or Terminal in Mac and Linux? In this video, you'll learn more about the core differences of running code from the command line via the IDE, as well as exploring ways in which you can run programs through Python. Let's explore the two main ways to run Python's programs. The first way is using the Python shell, and the second way is to run a Python file directly from the command line terminal. The Python shell is useful for running and testing small scripts. For example, it allows you to run code without the need for creating new .py files. You start by adding snippets of code that you can run directly in the shell. Let's explore the second main way to run Python's programs, which is running a Python file directly from the command line or terminal. Note that any file that has the file extension of .py can be run by the following command. For example, type Python, then a space, and then type the file name with a .py extension. VS Code is a better choice than using the Python shell or running it directly from the terminal because, besides including both of these options, it comes with a plethora of additional improvements that make coding in Python a better experience. Visual Studio Code also offers features such as auto-completion, debugging, and code syntax, highlighting, whitespace, and indentation helpers. I'm now going to demonstrate the different ways that you can run Python programs in VS Code. There are two options to run programs through Python. One is to run directly from the command line or the terminal if you're on Mac. And then the other option is to run directly from the IDE, which in this case is Visual Studio Code. Let's find out how to do this. First, I open the terminal window or command line window from within the IDE by clicking on the terminal menu and selecting New Terminal. Now I run the hello-world.py script directly from the terminal. So I can run this by typing the command Python, and then the name of the file hello-world.py, followed by the name of the file. Then hit the Enter key. The result is Hello World. There's a second option using the terminal, which is entering it into the Python shell. So if I only type the Python, hit the Enter key, it opens the Python shell approach. Here I can write code and run it directly within the terminal window. I can, for example, use the same code that I have above the print hello world code. I hit the Enter key, and that will print out the words hello world directly in the shell. Let's say I want to exit from the shell. I then type in the word exit. As this is a function, I must add the parenthesis, hit the Enter key, and now I'm back in the command window. To do the same from within the IDE, I just close the terminal window. Here I can run any Python scripts from the IDE directly by using the buttons in the top right-hand corner of the screen by selecting from the drop-down either the Run Python file or the Debug Python file. Now I click on the Run button and the terminal should open automatically. The result is Hello World that is printed. You have now explored the two options that are available for running Python code directly from the terminal or command line and from the IDE. That brings us to the end of this video. You now know the core differences of running code from the command line via the IDE. You are also able to demonstrate ways in which you can run programs through Python.
In this video, you'll explore Python syntax and learn how both whitespace and indentation can impact a program when used incorrectly. In VS Code, I create a new file called python_syntax.py. I start by using a print statement to generate a line of text. Don't worry if you're not familiar with print or variable declaration at this point, as that will be covered later in the course. I type print followed by the string hello. When I click on the Run button, the text hello appears in the terminal panel. Now let's say we want to use another print statement on the same line, which will output the text value world. So I add a space and then type another print statement with the string world, and we expect this to give us the words hello world. But when I click on Run, we actually get an error. Specifically, it says syntax error, invalid syntax. This happens because the interpreter doesn't know when the new line or statement occurs. There are two ways to solve this problem. One is to move the second print statement to another line. I do this by placing the text cursor before the print statement for world, and then pressing the Enter key to move it down one line. When I click on Run this time, there is no error and I get the words hello and world on separate lines. Let me undo the edits I made to my code by pressing Ctrl and Z or Command Z on a Mac, and then try the second method, which is separating the two print statements with a semicolon and a space. When I click on Run again, it also runs both statements as expected. Next, you'll cover the impact of whitespace in Python syntax. I first clear my screen and then declare a variable and assign it a value by typing x equals 1 plus 2. On the next line, I will add a print statement for x. Before I click on Run, however, I'll go back to my variable assignment and add a random number of spaces around the plus symbol. Doing this will not cause any problems with this line. However, issues will arise if I add a new line or an end statement. To demonstrate it, let's input a new line and type +3. Running this code then returns a value of 3. What has happened is that the interpreter has executed our first line of 1 plus 2 correctly, despite the extra whitespace, but it did not account for the +3 on the second line. There are a few ways to work around this issue. The simplest approach is to use a forced line. To do this, I type a backslash at the end of the first line. Now, when I click on Run, it returns a value of 6, which means that both lines have been accounted for. To summarize, any amount of whitespace or indentations on a line is fine, but keep in mind that if you are combining it with additional lines, then you will need to give clear indicators of where a new line has occurred. Next, you will explore indentation in Python. I start by clearing my screen and declaring the new variable name with a string value of John. I want to write an if statement which will return John only if the name variable has a new value of John. I do this by typing if name == John, and then on a new line, I input a print statement for name. To make this program work, I need to have an indentation before the print statement, which VS Code added automatically. When I click on Run, I get back John as expected. But what happens when the indentation isn't there? If I delete the indentation from my code and then run it again, I get the error indentation error expected in indented block. This tells us that an indentation was not found where it should have been. Fortunately, the error message directs us to the specific line where the issue was detected. I could then edit my code and fix it. When writing programs in Python, it's a good habit to read the output whenever you encounter an error, as you are often given the specifics of what went wrong and where it happened, as you noticed here.
Variables are an essential part of programming, and they are used to store all different types of data. You might even say they are the cornerstone of programming. This is because they allow you to work with and manipulate data. Therefore, it's important that you can identify variables and recognize how they are used. Declaring variables in Python is very straightforward. All you need to do is declare a name and assign it a value. The word variable refers to something that can be changed. To do this in Python for a variable that has already been declared, you only need to reassign or redeclare it. Let's explore an example. Let's say the variable x has been assigned the value of 10. To change this, you only have to redeclare it, so it will have the value of 20. The examples so far have relied on simple naming conventions such as x, y, and z. When working on a project with other developers, it will become increasingly difficult to know what these variables mean or refer to. As a programmer, you will write a lot of code over time, and if it's been a few months, you'll most likely not remember exactly what the code was supposed to do. Using generic variables like x and y doesn't give any information about that variable and where it is used. Giving meaningful names to your variables that make sense in the given context will allow you and other programmers to easily understand what's going on. As a programmer, it's important to understand that data will change throughout the life cycle of your program. Whether it's getting user input via a web form or working with variables inside a code itself, the key function of the variable is to keep a reference to some sort of value. Now that you have a basic grasp of variables and their role in Python, let's move on to a more practical demonstration of the variables and how to use them. I'll demonstrate how to use variables in Python, but first, I want to briefly talk about naming conventions. There are different options available to you as a developer when it comes to naming your variables. One option is called camel case. The first letter of the first word is lowercase, and the first letter of every word after that is uppercase with no spaces between words. For example, if I have a variable called my name, I'll put the m of my in lowercase and the n of name in uppercase, with the rest of the letters in lowercase and no space between the words. I can take a different approach with snake case. When using snake case, you keep everything in lowercase letters, but you use an underscore between words. So if I want to make the variable my name, my underscore name would be the result of this approach. Although you have different options as a developer, it's a good idea to be consistent when you are creating variables across your programs. Let me clear the screen so I can begin. So I create a variable in Python by initializing a variable and assigning it a value. All I have to do is name the variable. For example, if I type x equals 5, I have declared a variable and assigned it a value. I can also print out the value of the variable by calling the print statement and passing in the variable name, which in this case is x. So I type print x. When I run the program, I get the value of 5, which is the assignment that I gave the initial variable. Let me clear my screen again. You have several options when it comes to declaring variables. You can declare any different type of variable in terms of value. For example, x could equal a string called hello. To do this, I type x equals hello. I can then print the value again, run it, and I find the output is the word hello. Behind the scenes, Python automatically assigns the data type for you. You'll learn more about this in an upcoming video on data types. You can declare multiple variables and assign them to a single value as well. For example, making a, b, and c all equal to 10. I do this by typing a equals b equals c equals 10. I print all three values separately, and when I click on the run button again, I find that all three of those assignments have 10 as their value. Again, I clear my screen before I move on to the next example. Yet another option you have is to do multiple assignments. For instance, I type A, B, C separated by commas equals 1, 2, 3, also separated by commas. In this way, I have assigned each of those values to the corresponding letter. So A equals 1, B equals 2, C equals 3. To test this out, I can print all three variables. Click Run, and I'll find that the values 1, 2, 3 correspond to the declaration above. Another important point that you should be aware of is variable assignment and how you can change it. A variable is subject to change. Throughout the life cycle of your program, you will make changes to the value or the assignment of the variable itself, so you need to know how to do that. Let's explore another example. I type A equals 10 and I print that value. After this, I change the value of A to 5 and I print that value too. When I click the Run button, A prints out as 10 on the first line and as 5 on the line below because the value was reassigned. Finally, you need to know how to delete a variable. My variable is A, its value is 10, and I've printed it out. And then on a new line, I type the delete command, or DEL for short, followed by a space and the letter A, which represents my variable. I then print the variable by using the print function, and then I click the Run button. The value is first given as 10 because the variable still existed, but after the deletion, it shows an error saying that A is not defined. You just covered variable naming conventions. Now you know how to declare a variable and assign it a value, and you know how to declare any different type of variable in terms of value. You can declare multiple variables and assign them as single value, and you can do multiple assignments. Finally, you also learned how to delete a variable. That brings us to the end of this video. You can now identify variables and recognize how to use them in Python. Computer systems need to interpret different data values. In programming, data can come in different types. By the end of this video, you'll be able to describe the different data types in Python. A data type is an attribute associated with a piece of data that tells a computer system how to interpret its value. Knowing what data types to use ensures that data is collected in the preferred format. It also ensures that the value of each property is as expected. Python offers raw data types to allow data to be assigned to variables or constants. The 5 main types which are classed as literals consist of numeric, sequence, dictionary, Boolean, and set. Some of these data types can be extended. For example, the numeric data type can consist of types integer, float, and complex number. For now, let's just discuss data types in more detail, starting with numeric. In programming, you need to decide on what type will suit your needs. For example, when working with currency, you are most likely going to use the numeric type of float, as it allows decimal places to be counted. To determine a type of variable, Python also provides a function named type, which will provide the class type based on the variable being passed. Python offers 3 different kinds of numeric types, which are integers, floats, and complex numbers. The integer class represents any non-fractional number, that is, whole numbers with no decimal places. These numbers can be positive or negative, for example, 10 or minus 10. Floats are numbers that contain decimal places and are represented by the float class. Examples are 10.5 or 6.7. The complex class is used to represent complex numbers which are made up of both real and imaginary numbers. A equals 10 plus 10j. Next, let's explore the sequence data types. Sequence types are classed as container types that contain one or more of the same type in an ordered list. They can also be accessed based on their index in the sequence. Python has 3 different sequence types, namely strings, lists, and tuples. Let's explore each of these briefly, now starting with strings. A string is a sequence of characters that is enclosed in either a single or double quotes. Strings are represented by the string class, or str for short. Lists are a sequence of one or more different or similar types. They are essentially an array and hold any type inside square brackets. Each item can be accessed by its index. Tuples are similar to lists in many ways. They contain an ordered sequence of one or more types but the main difference is that they are immutable. This means that the values inside the tuple cannot be modified or changed. Tuples are represented by the tuple class and hold data types wrapped in parentheses. The next data type is dictionary. Dictionaries store data in a key value object structure. Each value can be accessed directly by its key. Dictionaries can also store any data type. For example, suppose you declare a variable named ed and assign a dictionary to it. The dictionary contains a grouping of key value pairs. The first pair is A, 22, where A is the key and 22 is a value. The second pair is B, 44.4, where B is a key and 44.4 is the value. You can then output the value of 22 by accessing its key, which is A. Next, let's explore Boolean data types, which are simply represented as true or false. Combined with logical operators, Booleans are used to check whether a condition is true or false. In this example, I'm checking the underlying data type of the values true and false. The class bool is returned, meaning it is Boolean. The last data type is set, which is an unordered and non-indexed collection of non-repeated values. Let me demonstrate an example of this data type. Suppose I assign a set of 4 items to the variable named example set. I then check the type of the value stored in the example set variable by passing it to the type function. Python reports that the underlying data type that the example set variable holds is a set. In programming, data type is an important concept. Variables can store data of different types, and different types of data can do different things. Let's explore these in further detail. Whenever you declare a variable in Python, the data type is automatically assigned for you based on the value of that variable. Let me demonstrate this by typing a variable called a and assigning it a value of 10. To check the data type that has been assigned by Python, I select print and use the type function. I then pass in the variable a as the parameter and click on run. From the output on the terminal, I can see a class of float was assigned because there is a decimal place. Here is another example. I'm using the variable b and I assign it a decimal value of 2.3. To check the data type assigned by Python, I print out type b and click on run. From the output on the terminal, I can see a class of float was assigned because there is a decimal place. This is a different assignment than the standard integer. These are the numeric data types offered in Python. To declare a variable as a string, I wrap the text with single or double quotes. Again, I run the print statement with the function type and pass the variable c as the parameter. When I click on run, the output in the terminal now displays the classes int, float, and str for string. This sequence is also applicable for other data types. For example, I can create a list of numbers by using the variable d and assigning it the numbers 1, 2, 3, 4. When I run the print statement with the function type and pass the variable d as the parameter, the class list displays after I click run. Each time I assign a value to a particular variable, Python behind the scenes is automatically assigning the correct data type for that variable. In this video, you learned about the different data types in Python. I encourage you to start experimenting with these data types in your practice code. You may recall that Python can work with several types of data. In this video, you'll learn how to declare and use strings in Python. You'll also gain a general understanding of sequences and how to access individual items in a sequence. In Python, a string is a sequence of characters enclosed in either single or double quotes. As you may know, computers only understand binary code, which consists of ones and zeros. This means that characters need to be converted to a form that computers can interpret, a process known as encoding. Python uses a type of encoding called Unicode to communicate with computers. Strings in Python can be declared in several ways. For example, for a single line, you can type the variable name followed by an equal sign, and then the characters encased in quotes. If your string is too long for one line, you can add a backslash at the end of each line to create a multi-line declaration. When you run print on your variable, all those strings will be combined and appear on one line. If needed, you can reassign the value of a string. Say, for example, the variable name has a string value of John, but you want to change the value to Paul. This can be done simply by typing name equals Paul. Now, when you run print on name, this update should be reflected. It's important to know that a string is just a sequence of characters, which in turn means it is essentially an array. Each character in the sequence can be accessed based on its index. For example, Python strings use zero indexing, so you can access the first character with the number 0 in square brackets, or the number 2 to access the third one. If you need to check the length of a string, Python has functionality to assist you. You can apply the len function to a variable with a string value. This will then return a number that represents how many characters are in the string. Now that you have learned what strings are in Python, let's explore some code examples of strings in action. First, let me demonstrate the two ways to declare a string. The first method is by placing the characters inside of single quotes. So I type A equals and then hello in the quotes. On the next line, when I type print followed by A in parentheses and then click the run button, my code returns the string hello as the output. The second method is similar but uses double quotes. So I would enter it as B equals hello with double quotes. When I run the print function again, it also returns the string hello. Both quotation types are equally valid declaration methods. The choice is a matter of personal preference, but it's best to pick one option and use it consistently throughout your code. In addition to the quotation types, you can declare single-line or multi-line strings. An example of a single-line string can be A equals, this is a single line. I asked to print out the value of A. When I run it, the value is printed out as I declared it. However, there may be cases in which a string is very long, and you want to break it up into segments to make it more readable. To do that, I can use the / key to create a multi-line string. To declare a multi-line string, I type B equals followed by the string this is a multi. Before continuing, I add a / at the end of this line. On the next line, I type the continuation of my string, line string example. Note that I enter a space before the word line, so that it's separated from the last word of the string on the previous line. And now when I run print on B, the / has the effect of joining both segments so that the output appears as a single string. Another thing you can do with strings is concatenation, which is the joining of separate strings. To demonstrate this, I first create two new variables, A equals hello with a space at the end, and B equals there. When I run print this time, within the parentheses, I type A plus B and get back both strings joined together. The plus symbol is usually used as an arithmetic operator, but when applied on strings, it combines them instead. And one more thing to know about strings is that they are considered collections of characters. What this means is that, much like an array, you can access individual characters based on an index, and you can also check the length of a string using the len or len function. To give an example, I create a name variable with the string value John. Now I want to print only the first character of this string. To do so, I run print on name, followed by the character index number inside square brackets. Strings in Python are zero indexed, meaning that the sequence count begins from 0. So 0 is the number that I place in the brackets. When I click on run, I get back the letter J. If I change the number to 3 and run it again, I get back the letter N, the fourth character in the string John. Next, let's check how many characters are in this string by using the len function. I start a print function, and in it I type len followed by name inside of parentheses. When I run it, it returns 4 as the length. In this video, you've learned about strings in Python. Specifically, you now know how to declare and use them, and understand that they are sequences of characters. See you in the next video. Python uses different data types to process and use information effectively. Sometimes you need to change the data type of a variable after you've collected values for it. Let's say, for example, a user submits a form on a website, and one of the fields was an integer, but the data was passed as a string. This is a problem because the only way to perform calculations with the number saved as a string is to convert it to an integer data type. To do this, you can use typecasting in Python. In this video, you'll learn about 2 different typecasting methods in Python. You will also learn to apply typecasting using the provided Python functions. So, what is typecasting? Typecasting is the process of converting one data type to another. Python has two different types of conversions, implicit and explicit. Let's explore each now in a little more detail, starting with implicit. Implicit data type conversion is performed automatically by Python's compiler to prevent data loss. It will convert, for example, an int to a float if it picks up that the inserted value is a decimal. It's important to note that Python will only be able to convert values if the data types are compatible. Int and float are compatible, but strings and int are not. So if data types are not compatible, Python will throw a type error. Alternatively, developers can perform typecasting with the explicit data type conversion. You do this by using the provided Python functions. There are many functions, but some of the most common are string, integer, and float. Let me take you through some of these functions and how to use them. First is the string cast function. This is used to convert any data type into a string data type. To use this function, you type str followed by the value that you want to convert between parentheses. Next is the int typecasting function. To use this, type int followed by the value that you want to convert between parentheses. The float function is another common type of casting function. Once again, you type the word float and add the value that you want to convert in between parentheses. Python has many more typecasting functions, and they also have a similar structure. They are odd, which returns an integer representing the underlying Unicode character. The hex function, which converts a given integer to a hexadecimal string. And oct, which takes an integer and returns a string representing an octal number. There are also tuple, set, list, and dictionary, which you will learn more about later in the lesson. In this video, you learned about typecasting in Python. It's important to remember that data types are not unchangeable. You can convert data types using the provided Python functions if you need to. In programming, it's important to understand how to control the order in which your code is executed. For example, suppose you're invited to an event. You have to consider whether you need to dress formally or informally. Another example of a control flow is to consider a light switch. The flow is represented by the electrical current and the control as the switch itself with the two states of on and off. The order in which you make decisions matters, and the same applies to writing effective programs. In this video, you'll learn how to use conditional statements to control flow in Python programs. So, what is control flow? Control flow refers to the order in which the instructions in a program are executed. All programs have decisions that need to be made. As a result of this, the program will take different actions or directions. In Python, there are two types of control flows. First, you can use conditional statements such as if, else, and elif, or else if. And second, you can use loops such as the for loop and the while loop. Let's explore these a little further now. The if keyword states that if the condition proves to be true, a function is performed. The else keyword catches anything which isn't caught by the preceding conditions. The elif or else if keyword is Python's way of saying, if the previous conditions were not true, then try this condition. The for loop checks for specific conditions and then repeatedly executes a block of code as long as those conditions are met. The while loop repeats a specific block of code an unknown number of times until a condition is met. Let's explore conditional statements in more detail with some practical examples using the if, else, and elif. I'll now write some code for a restaurant that wants to apply different discounts based on the amount its customers spend. To start off, I define a variable for the customer's bill. I'll call it bill total and assign a value of 114 to it. Now I apply a condition with an if statement. If bill total is greater than 100, print the statement bill is greater than 100. Next, to apply a discount to bill total, I need to create a second variable. I'll do this above the if statement in my code, call it discount1 and assign a value of 10 to it. The condition also has to change. So inside the if statement, I add bill total equals bill total minus discount1. At the very end of the code snippet, outside the if statement, I'm going to print out what the value of the total bill is. To do this, I type a print statement that says total bill and then a plus sign. To add the value of bill total here, I need to convert the integer to a string. I use the str typecasting function to do this. Let's click on Run. Great. In the terminal, two strings are printed. Bill is greater than 100 and the total bill is 104. But what happens if the bill is less than 100? I change the value of bill total to 95 and press Run. Notice that this time, because the if condition is not met, it only prints the statement total bill is 95. But I'd like to print a statement that says the bill is less than 100. To do this, I add an else statement below the if statement. I type else, and in the next line, I print the statement bill is less than 100. Let's run the code. The output in the terminal now says bill is less than 100 and total bill is 95. Up to this point, you've learned how to use the if and else statements to control the order in which values are assigned and printed. You are now ready to take program flow one step further. Say this restaurant wants to add another discount for bills over 200. How would you do that? Once again, I first need to create a new variable above the condition that I name discount2, which I set equal to 20. If I run the code now, it will still print out the same output because I haven't changed any of the conditions or values yet. Let's change the value of bill total to 210 and click Run. Notice that both statements are printed, but discount one is still applied. It's clear that the if statement is still executed. Since the value is 210, the condition is still met. To change the program flow for values over 200, I need to add an AND condition to the if statement. I change the statement to if bill total is greater than 100 and bill total is less than 200. Let's run the code and see what happens. Now the discount wasn't applied. The output just says bill total is 210. Why? Because the condition is not met. Now this is where it gets really interesting. To add a second condition for bills above 200, I'll use an else if statement. In between the if and else statements, I type elif, which stands for else if, and then bill total is greater than 200. Print the statement bill is greater than 200. In the next line, I apply the new discount. I type bill total equals bill total minus discount 2. First, let me clear my screen so you can focus just on the results. Now I press Run. Notice how the program flow has changed. The first condition was not met, so the code went to the second condition where the value of bill total was compared to 200. And since it was greater than 200, the statement bill is greater than 200 was printed. The code then proceeded past the else condition because the previous elif condition was true. Remember, the else condition only executes if none of the preceding conditions are true. Finally, it printed the statement at the end of the code snippet, namely, total bill is 190. This proves that discount 2 was applied. Congratulations! You now know how to control program flow with if, else, and else if. Once you become proficient in using conditional statements, programming becomes a lot of fun. I encourage you to test it out. In this video, you learned how to use conditional statements in Python. Writing conditional statements is an essential part of programming, and I encourage you to practice them in your code. The next time you need to make a decision, think about the conditions involved and how they can be represented if you were to code them in Python. You may recall how to use the if, else, and else if statements to test a variable against a few conditions. But on some occasions, you will have to test a variable against many conditions. To deal with this, you can use something called a match case statement. In this video, you'll learn how to use a match statement as an alternative to an if statement. Now let's consider an example to compare the match statement to the if statement. Say you want to write code to print HTTP error messages according to error codes. To do this with the if statement, you would have to write the if condition, all the alternative if-else conditions, and finally an else condition. Conditional statements like if, elif, and else work well over a small number of conditions, but over a large number of conditions, your code can get large, complex, and messy. Fortunately, there is a cleaner way to achieve the same result using the match statement. The match statement in Python was introduced in version 3.10. Using the match statement, you can achieve cleaner, more readable code that allows all the same functionality as the if control statement. When using match statements, there are a few things to remember. You can combine several conditions by using the OR operator in the conditional statement. The default is essentially the final outcome if nothing is found in the case checks. It's the equivalent to the else in the if blocks. Let me demonstrate this example now using VS Code. Okay, so I've written a simple if statement that checks for an HTTP status code. If the value of the variable HTTP status matches one of the conditions, it will print out the equivalent message. I'm now going to add a match statement below the if statement. For a clear comparison, I will test the same variable against the same values. I type match and then the variable HTTP status and a colon. On the next line, I type case, which is the equivalent of the word if, and the value of 200. On another line, I repeat the action used in the if statement for 200, which is to print the word success. So in other words, the variable is matched against the value of 200, and the if values are equal. It will print out the word success. Notice that the value of HTTP status is indeed 200 at the moment. So let's run the code to test how the if and match statements are processed. In the terminal, the word success is printed twice because the value of HTTP status is matched twice in my code run, once for the if statement and once for the match statement. Now let's change the value of HTTP status to 201 and run the code again. In this case, success is only printed once. Why do you think that happens? Because there is an OR condition for the value of 201 in the if statement, but none in the match statement. To do the equivalent in the match statement, you use the OR operator. So I place my cursor in between 200 and the colon and add an OR character and the value of 201. I clean my screen by using CLS and then click on Run again. Now success is printed twice again. So in the match statement, the pipe command is shorthand for if, or. The great thing is that you can add many case statements in a match statement. But what if none of the values match the variable's value? Now let's change the value of HTTP status to the value of, say, 550 and explore what happens. I click on Run, and this time the word unknown is printed. You may be wondering why that is. Because the else statement is like a catch-all. If the value does not match anything within the if or the elif statements, the default will be the else statement, which in this case has a print function for the word unknown. Well, the match statement also has a default class, and you add it by typing the word case underscore colon, and on the next line, print unknown. Let's run the code again. Great, the output is unknown, which means that the default statement in both the if as well as the match statement was actioned. My match statement is coming along well, but it still needs a few tweaks to make it act exactly like the given if statement. To do that, I'll add a few more case statements that will test for the same values as the elif statements. I type case 400 colon, and then I add a print command with the words bad request. I add another case and the value of 500, and I also need to test for 501 like in the elif statement above. So once again, I add an OR character and type 501 colon. On the next line, I add the error message that I want to print, which is server error. The match saves a bit of space by combining the OR statement, so you don't have to do a comparison against a variable each time like in the if statement. Let's change the value of HTTP status one more time to 501. I just clear the screen again and click on Run, and server error is printed for both statements. Now you know that there are some differences between the two, but the match statement does exactly the same as the if statement. In summary, the match statement compares a value to several different conditions until one of these conditions is met. So you now know how to use the match statement as an alternative to the if statement to test a variable against many possible values. The match statement is relatively new to Python. Prior to version 3.10, developers had to get creative and code their own solutions. You'll learn more about those alternative methods later in this lesson. In Python, nested loops can be used to solve more complex problems. For example, the nested for loop is written by indentation inside the outer loop. Let's explore this further now and break down how a nested loop works. First, the outer loop will start and then step into the inner loop. Then the inner loop will run until its range limit is met, 10 in this case. Once the inner loop completes, it will come back to the outer loop for the next iteration and then step into the inner loop again. This will happen until the outer loop has reached its limit. Now let's explore an example using nested loops to iterate over two lists. For example, suppose you have two lists of integers from 1 to 9 and a count variable that is set to 0. You again have two loops, the outer loop which will iterate over list 1 and the inner loop which iterates over list 2. If you run this code, it gives an output of 90. Let me break it down for you. The outer loop runs a total of 9 times. The inner loop runs a total of 9 multiplied by 9, which is 81 times. And 9 plus 81 gives a total of 90. To help visualize how this would look, you can make some minor changes to the loop to output what it looks like. Okay, so you now know that the number of times a loop is run is based on the size of the list. Now that you've learned about nested loops, let me demonstrate some code examples of nested loops. So I have VS Code open, and first let me start with a simple example and write a for loop. I type for I and I use the range function, so I have in range 10. Above the loop, I label it with a comment outer loop. This first for loop is considered an outer loop, and inside I will have an inner loop. I write a comment inner loop right under the first for loop. Now I type for j in, then I use the range function again, and I pass in a 10 and end with a colon. The 10 indicates the number of times the loop will iterate or repeat. In this example, I print out 0, and then I use end equals and a string with space in double quotes to ensure it prints out in an even manner. And lastly, I'm going to print out an empty line so that it goes to a new line in each iteration. If I run the for loop, the system prints out a 2D array grid. This is just to demonstrate how the for loop works. If I want to print out a single line, I can change the outer loop to 1. I clear my screen, run it again, and this time a single line of zeros is printed out because the outer loop only iterated once. This is all based on the outer loop only. It runs once, but when it goes to the inner loop, that it runs 10 times and prints out a 0 for each item on the same line. Every time the outer loop starts, it will go into the inner loop. The inner loop must finish before it comes back to the outer loop to start on 2, 3, 4, and so on. I can showcase that by simply changing the outer loop range to 2. In this case, only 2 lines are printed. So the first when I equals 0. It comes into the inner loop and prints out 10 times. When that's finished, it comes back to the outer loop. Then I is incremented again to 1, and then it'll be printed out from J's inner loop and another 10 zeros again. The other issue to consider with nested loops is the complexity, or what is commonly known as time complexity. The larger the array, the more time it's going to take to run my code. Let me showcase this by running a for loop for a larger range, but also putting a timestamp on it. I import the time module to put a timestamp in what's printed out. I class it as the start time equals time.time, which is the function that I want to call. The start time is initialized the moment I run the script. I also want to print out how long it took to finish. I do that by putting a print statement outside the for loop. I then calculate the time as in the time it took to finish and then subtract that from the start time above. This is going to print out many decimal places, so I use another function named round, which rounds numbers to a decimal of my choice. In this case, I round it off to 2 decimal points. Let me clear my screen one more time. I click on Run, and it outputs the time of 0.0 seconds. This makes sense because the time my code takes to run is really short. Now let me increase the range in the outer loop to 100, and I also increase the range in the inside loop to 100, and I click on run one more time. The time now goes up 0.01. In this case, it's not a big difference, but when you're dealing with large data sets, this will have a huge effect on the running time of my code. This time, let's say for example that I keep the outer loop to 100, but I increase the inner loop to 1000. I clear the screen and click on run. The time increases to 0.04. If I increase the inner loop one more time to 10,000 and I clear the screen and click run, now the time goes up to 0.45. So the larger the array or the larger the range, in this case, the more time it's going to take for a program to complete. It's always important to remember how you can optimize code to make it run more efficiently, and consider the amount of time your code will take to run. You just covered nested for loops and learned about the issue of time complexity. In this video, you learned about nested loops and how they work. Congratulations on reaching the end of control flows and conditionals, and the end of the module on getting started with Python. Let's recap what you've learned. So now you know how to explain the history of programming and how it works in a general sense. Describe the benefits of Python and where it's used. Evaluate if your system is set up correctly for Python development. Identify the differences of running code from the command line via the IDE. Explain the importance of syntax and space in Python. Describe what variables are and how they are used. Identify data types in Python. Explain how to declare and use strings. Describe the two types of casting and how to apply them. Describe the basics of user input and console output. Recognize math and logical operators in Python. Use conditional statements to control the flow of programs. Use match case statements as an alternative to if statements. Explain looping constructs and how to use them. And explain nested loops and how they work. You've learned a lot about the structure and rules that guide Python, and now you're ready to create programs. Great work. See you next time. So, what are functions? At the most basic level, you can think of functions as a set of instructions that take an input and return an output. For example, the primary task of the print function is to print a value. This value is usually printed to the screen, and it's passed to the print function as argument. In the example we have here, the string hello world is the value passed to the print function. By the end of this video, you'll be able to declare a function in Python, pass data into a function, and return data from a function. A Python function is a modular piece of code that can be reused repeatedly. You've used some Python functions already in this course, such as print and input. Both are functions, and each one has a specific task or action to complete. The input function will accept parameters too, but will also accept input from the user. So, how do you declare a function? A function is declared using the def keyword, followed by the name and task to complete. Optional parameters can also be added after the function name within a pair of parentheses. Here's an example of creating a function to add two values. Type the def keyword, followed by the function name of sum, then enter x and y as parameters. And finally, enter return x plus y as the task to complete. I'll now give a practical demonstration of functions, how to declare them, how they're used, and how they can also simplify your code by putting it into a reusable structure. Let's start with a short example that explains how to calculate a tax amount for a customer based on the total value of that bill. I'll start by declaring two variables. I type the first variable called bill, and I assign it the number, let's say 175.00. I know this is going to be a data type known as floats because I'm using decimal points, as is the norm for currency. The second variable is the tax rate, which is the percentage tax rates that should be applied to the bill. So I put in 15, and then what I want to do is calculate the amount of tax for the bill itself. What I do is add this into another variable called total tax. I then do the calculation, which is the bill multiplied by the tax rate and then divided by 100 to get a dollar amount. To output the value, I print the total tax and pass the total tax variable and then run the program. Total tax is 26.25, which is 15% of 175. In the real world, the bill value will be different for each customer, and the tax rates may also change. Updating each variable every time is inefficient. To overcome this problem, I'll create a reusable function. To start creating a function, I use the define command, or def for short. Then I'll give it a name that relates to the task it's carrying out. So in this case, it's going to be calculate tax. With functions, you can pass in arguments, and the purpose of that is to make it more dynamic. So consider the arguments that I need to take in. I'll take in a bill, which would be the total value of the bill itself, and then also a tax rate. And then, like I've done before, I will calculate the total tax by taking the bill, multiplying it by the tax rate, and then dividing it by 100. Okay then, I do a return, wrap bill in parenthesis, multiply it by tax rate, and divide by 100. Now I can remove the declaration I made earlier for the variables and the calculation. With a function, if you run the current code as is, it will come back with nothing because a function is only ever run when it's actually being called. I'll demonstrate this. If I do a print, I can calculate tax, and then I pass it as I've done earlier. 175 is the total bill, and then the tax rate will be 15. I'll also put in just a total tax and then click on run, and the total tax rate is 26.25. If I want to change the rate, I can reuse the same function, total tax. I'll call the function again, calculate tax. I'll give it a different value for a bill, say 164.33. This time I'll change the tax rate to 22%. Clear the screen, and then click on run, and my total tax for the second item is 36.1526. To clean the output up a bit and make it more visually appealing, I'll put in a round function which allows control of the number of decimal places that I want returned. In this case, I'll do 2, and then rerun the code. This is a lot neater, with 36.15. One of the nice things about a function is that you can update it once, and any part of the code that calls that function will get those changes as well. In this video, you've explored basic functions in Python, how to declare functions, and pass and return data to and from them. Lists are a sequence of one or more different or similar data types. A list in Python is essentially a dynamic array that can hold any data type. Let's move to the console and I'll demonstrate some practical examples of Python lists. First, I'll go through a few examples of declaring lists. So I create my list by typing list1 equals and then the numbers 1, 2, 3, 4, 5 within brackets and separated by commas because you use commas to separate items in a list. List2 is a list of strings A, B, C. I can also have a list of different data types. For example, in my list 3, I can have a string, an integer, a boolean, and a float. So the type doesn't necessarily matter. It's just going to be stored in the same way. One thing to keep in mind with lists is that they are based on an index. For example, let's suppose I wanted to access the number 3 from my list1 example. Since the index always starts with 0, I'd have to write list1 open square bracket 2 close square bracket. This gets the third item in the list, which is number 3. So if I do print that, I get the value of 3 being printed out. An important option with lists is that you can also have nested lists. So if I declare another list, for example, list 4, and I put in 1, and then I can have a nested list of 2, 3, and 4, and then get back to a 5 and 6. That's completely valid as well. So any data type can be stored within the list itself, just to keep that in mind. Let's see what else lists can do. I've got a few different options to add items to a list. One is to use the insert function. So just before I do that, I'll just do a print. To print out the entire list, there are a couple of different ways I can do it. I can use the star sign list1, click on run, and I get the entire list printed out. To print it the way it is displayed in my code, I can use the print statement type in list1 and just put in a separator, equals, and then comma, or just single space. I click on run and I get this type of print returned. Right, back to adding something new to the list. The first option that I have is what's called the insert function. I can do list1.insert, and what it looks for is the index of where to insert to. Here I can use the len or len function to get the length of the list1. Then I put in what the next value should be. So in this case, I put in number 6. I do the same print statement directly underneath that. Then click on run, and I find that I get 6 added to the end list. I can also use another function called append. Instead of having to specify the index or where the item should be placed, I can just put in the append keyword. So I type append 6 and click on run, and it's added in without having to specify the index. There is another function I can use if I want to add one or more items to the list. It's called extend, and this will accept a list as well. I can put in extend 6, 7, 8, 9, and then click on run, and then my list is extended with 6, 7, 8, and 9. To remove something from a list, there are a few different options. The first way is to use pop, and then specify the index or location of which item I want to remove. To demonstrate pop, I'll say pop4 for index 4. I click on run, and the last item from the list is removed. Remember, within a list, the index always starts at 0. So index 4 means the 5th item being the value 5, and that's what has been removed. Another option is the delete or del keyword. I can say del list1 and then specify the index to delete. In this case, I put in the index of 2, click on run, and the index 2 is removed, which in this case is the number 3. 0, 1, 2 is the number 3. Lastly, I can iterate through a list. One of the main reasons I use lists is that I can iterate through the values and gain access to large amounts of data. So to iterate, I can use a simple for loop. So for x in list 1, and then I can do a simple printout. I'll just remove this one underneath. I'd like to print out the value of x, so I just put in print value and then x. When I click on run, it'll print all values of the list. That's a brief demonstration of what you can accomplish using lists in Python. You just covered how a list in Python works as a dynamic array. You explored lists and learned how to use inbuilt functions of a list to access the list items, modify them, add to the list, and remove items from the list.
In this video, you will learn about sets and how they can help with storing certain types of data in different types of formats. First, I declare a set. I can start by declaring a simple variable called set A equals, and then use curly braces to define the set itself. Then the values go inside the brackets. I put in 1, 2, 3, 4, and 5. I'll do a simple printout to prove that we have a set. I click on run to get the values 1 to 5 printed out. Sets differ slightly from lists in that they don't allow duplicate values. I can demo this by putting in another 5. When I click on run, I find that the second 5 is not printed out in the list. Sets also have methods that we can use. I can use a method to add new content. If I use set.add6, I can add in the number 6. I click on run to find that the value 6 is added to the set. I can also use the remove method. I'll remove the number 2. When I clicked on run, I found that the number 2 was removed from the set. There's also discard, which essentially does the same thing as remove. Using discard, when I click on run, I'll find that I get the same output. Let me clear the console before we go any further. There are also a few useful methods that could be used with sets to perform mathematical operations. Let me demo some of them now. First, I will create a new set, set B. I will put in 4, 5, 6, 7, and 8, and reset the values of set A to the original values. There are two ways I could use mathematical operators. For instance, for a union join, I can do set A.union and then pass in set B. Then I can click on the Run button to see what happens. I discover that it joins the two sets together minus the duplicate values like 4 and 5. Union merges them into one. So you have a set 1, 2, 3, 4, 5, 6, 7, 8. For the other options for union, I can use the vertical line symbol or the OR symbol, and that works in the same way. Let me clear the console before we go on. Another operation I can use is the intersection. I can apply this to set A by writing set A.intersection and passing set B as the argument. When I click Run, I get back all the items that match in both set A and set B. Here we have 4 and 5. The intersection can also be represented by the ampersand and will work in the same way. When I click on Run, I also got back 4 and 5. Let me clear the console again before we continue. Another mathematical operation I can use is the set difference. To use this, I'll print set A dot difference set B, and this should give me back all the elements that are only in set A and not in set B. When I clicked Run, we got the correct output of 1, 2, and 3. I could also represent difference by using the minus symbol. When I click on Run, I'll also get back the same values. 1, 2, and 3. The last operation I'll discuss is what's called symmetrical difference. This is represented by the symmetric difference function, which is used in a similar way. When I click on Run, I get back 1, 2, 3, 6, 7, and 8. In other words, all of the elements that are present in set A or set B, but not in both sets. Symmetrical difference can also be represented by the caret operator. When I click on Run, I get back the same values. An additional important thing about sets is that a set is a collection with no duplicates, but it's also a collection of unordered items. Unlike a list where I can print out content based on index, if I try to print out set A brackets 0 to get the 0th element in the set, I'll get an error. Let me clear my console before we attempt to print this output. When I click on Run, I get back a type error saying that the set object is not subscriptable. This means that the set is not a sequence. It doesn't contain an ordered index of all elements inside. Okay, that concludes our gentle introduction to sets. Great job.
So, what is a dictionary in Python? In many ways, it's very similar to how an actual dictionary works. In a normal dictionary, to locate a word, you look it up by the first letter and then use the alphabetical ordering system to find its location. Likewise, Python dictionaries are optimized to retrieve values. You may remember how useful Python lists are to access an array of values. Dictionaries access values based on keys and not an index position. Therefore, they are faster and more flexible in operation. By the end of this video, you'll be able to explain the purpose and function of dictionaries in Python and identify the performance benefits of dictionaries. With a Python dictionary, a key is assigned to a specific value. This is called the key-value pair. The benefit of this method is that it's much faster than using traditional lists. To find an item in a list, you need to keep reviewing the list until you locate the item. But in a Python dictionary, you can go straight to the item you need by using its key. A dictionary is also mutable in that the values can be changed or updated. For example, you could declare the number 1 as the key and coffee is the item, and then change these to any other number or drink item. But how does this work? How do you access or locate the item you need within a Python dictionary? With the use of the keys. To demonstrate this, I'll access the coffee item within a Python dictionary. First, I declare my dictionary name as sample dictionary, then an equals with a series of key-value pairings or keys and items in a pair of curly braces. I also make sure to separate each pairing with a comma. I then type the print function, followed by the name of my dictionary. I need to access coffee item, which has been given a key of 1, so I insert the number 1 in square brackets. I run the print function and it returns coffee as a result, just as I intended. I can also update a dictionary by replacing one item with another. I just need to use the key to reference it while using the assignment operator of equals to assign the value. For example, I can change item 2 in my dictionary from T to mint T. I just write a new line of code that starts with the name of the dictionary followed by the key I want to change in square brackets. Then I add an equals operator followed by the name of the new item. What the coding says is to take item 2 in the sample dictionary and change it to mint T. When I run this function, it changes the item. I can also delete an item from the dictionary. To do this, I write a line of code with the delete function followed by the name of my dictionary. Then I add the key for the item I want to delete in square brackets. In this instance, I want to delete item 3, juice. When I run this delete function, it will remove the juice value from my dictionary. Finally, I can also use 3 different methods to iterate over a dictionary. I can use the standard iteration method, the items function, or the values function. Let's explore these iteration methods and the other dictionary operations functions in more detail. To create my dictionary, I'll start by declaring a simple variable called my_d, and then use the assignment operator and then curly brackets. It can be the same as a set, but by default, that's classed as an empty dictionary. I can print that out by using a print statement, using the type function, and then passing in the my_d variable, clicking on run. The class has actually come back as a type dictionary. So next, I'll add some values into the dictionary, and I need to do it in 2 parts. A dictionary holds what's called a key and a value. The key can be numeric, it can be string, but to signify the assignment, I use a colon and then put in whatever value that I want. In this case, I'll put in a simple string value of test. To signify that I can change or have different keys, strings, integers, or ints, I put in a string key of name and then the value Jim. I print out my dictionary using the print function. I now have a basic dictionary setup with a key of 1, name, and then 1 being test, name being Jim. If I want to access a key in the dictionary, I just have to use the square brackets and then pass in the key value. So in this case of 1, I'll pass in the numeric 1. In the case of the string value, I just need to pass in the actual string value itself, so name. Click on run and I get back both test and Jim, which are the values for each corresponding key. If I want to add a new key into the dictionary or update it, I can simply do my D and then add a new assignment, 2 in this case. Test 2, click on run. The key is then added with the current dictionary. To update a key, I have to call out the value that I want. I'm just going to update the first key, which is number 1 with a value of not a test, instead of test. Click on play and it's updated on the screen. The other thing to note about the dictionary is that if I try and put in a duplicate key, it doesn't allow this. So if I put in a number 1 and then not a test, click on run, and the key will actually be overridden with the latest one. So number 1 only appears once in the outputs and it doesn't allow the 2 keys to be printed out because it won't allow duplicate values to be set. If I want to delete a key from the dictionary, I use the del operator. Now I type my D and then specify which key I want to delete. In this case, number 1. It's then removed from the dictionary. With a dictionary, I can also iterate though. For example, I can use the for x in my dictionary and then print out the value of x. Click on run and I get 1. This only prints out the keys. In a lot of cases, I may need access to both. To do that, I use a method called myItems. With that, I can then gain access to the assignment of both the key and the value. So I do a printout here, key plus value. I'll use some concatenation to print out both the key and the value. Click on run. I have to be mindful because I'm using an integer with a string. So I wrap that with a type str, click on run again, and I get the value of the key and the value for each of the items in the dictionary itself. You should now understand the purpose and function of dictionaries in Python and their benefit in terms of performance. In this video, you'll learn about errors and exceptions, 2 very important aspects of learning Python as a new developer. You'll cover the difference between errors and exceptions and explore what happens when something goes wrong with your code. Errors are a part of coding and they happen for many reasons. Let's start by exploring two types of errors. Syntax errors, which are caused by human error, and exceptions, which are known errors that need to be handled. Syntax errors are usually caused by the developer. It could be the result of a misspelling or a typo in the code. Generally, these types of errors have minimal impact because most IDEs, like Visual Studio Code, will warn the developer and give clues about how to fix them. A common error for new developers learning Python is not adding the colon at the end of conditions or statements. If you're using a code editor with syntax checking, errors like this may be highlighted at the point of the error. For example, a missing colon will be highlighted in the code. The output will indicate the file name and the line where the error occurred, with a caret character pointing to the error. Running the code will result in an invalid syntax error, informing that there is a syntax problem. Other common mistakes include indentation problems, which are also syntax errors. For example, if there is an indentation problem, the error code will be indentation error. The more you learn Python, the less you'll have to deal with these types of errors because you'll become better at creating and analyzing your code. Now let's move on to exception errors. They happen during code execution and they can easily go unnoticed by the untrained eye. But exceptions need to be handled by the developer. They need to deal with any potential issues in the code base to keep the application from failing. Let's explore an exception being thrown. As an example, your code can be syntactically correct, but if it attempts to divide 5 by 0, it doesn't make mathematical sense. Therefore, when you run this program, the zero division error exception is thrown. Luckily, by default, Python includes many exception errors that you can use to pick up potential issues in your code. In this video, you explored the basics of errors and exceptions, which is a step in the right direction to becoming a better Python programmer.
In this video, you'll explore how to handle exceptions in Python. You will learn how to change error messages and how to wrap your code within try and except statements. As an example, I will write a simple math function. I define a new function called divide by and allow it to accept two parameters, a and b. The purpose of this function is to return the value of the division of both numbers. So, in the next line, I'll type return a divided by b. Now, I add a print statement for the divide by function. Inside the print statement, I'll also add a new set of parentheses with the value of 40 and 4. These are the values that will be divided by the function. I click on run, and the value returned is 10, which is correct, because 4 goes into 40 10 times. Now let's test what will happen if I pass in the values of 40 and 0. Now when I click on run, I get an error or an exception. The exception in this case says, 0 division error, division by 0. It gives this error because in math, you can't divide a number by 0. You might agree that getting cryptic errors could upset users. So, the question is, how can you handle errors in a more user-friendly way? How can you prevent a user from seeing the actual exception being printed out? You do this with Python's try and except statements. Simply type try, colon, and in the next line, except, colon. You add the code that you want to run within the try statement. So, I delete the print statement at the bottom and cut the divide by 0 function. Within the try statement, I type ans equals and paste the function. Now, in the except statement, I will add my own error statement. I add a print statement for the string something went wrong. Let me just clear the terminal so you can focus on the output. I click on run, and now the error statement is printed. So, what's happening? The try statement will try and execute the code that you added inside it. If an exception occurs, it will trigger the except line and execute any code added underneath the except statement. But Python allows you to make the except statement more specific. If you want to trap the exception itself, you could add the base class exception right after except. The base class exception is used for all exceptions that are written within Python. You can gain access to the exception information by using the as e after exception. The e variable acts as an alias for the exception. I can use e to print out the exception in the print statement. So, let's edit the print statement. I add e at the end of the error message. I press run, and what happens? Our custom message is printed out, but the contents of E are also printed. So this time it reads, something went wrong, division by 0. In Python, you could also get access to the actual type or class of exception that's occurred. To do this, I add another print statement of E dot underscore underscore class underscore underscore. I run this statement one more time. This time, the output includes the class of error as well, namely class 0 division error. Let me clear the terminal again. Let's take this one step further to provide even more specific feedback to the end user. In the except statement, I replaced the base class exception with the actual error that was printed out, namely 0 division error. I will change the print statement so that it first prints the actual error by adding E at the start of the statement. And now I'll add some user-friendly text saying we cannot divide by 0. I click on Run, and now the output is division by 0, we cannot divide by 0. Up to this point, you've covered how to wrap your code with the try and except statements and how to optimize the message that a user sees. But how can you handle more than one exception without knowing what they are ahead of time? Fortunately, you can chain the except statement by adding another except statement. Say the code doesn't trip the 0 division error in the first except statement. You could add another except statement that tests for a generic exception. Now I will add the base class exception. Again, I add a print statement with E and a message with some general information. I'll click on Run, and in this case, because there is still a math error, the function will still trip at the first except statement. But this gives you a good idea of how you can test for more exceptions. Congratulations! You now know how to wrap code in the try and except statements to handle all potential exceptions in your code.
File handling is an essential part of learning Python. Python has several built-in functions to create and manipulate files. File handling includes opening, reading, and writing files, amongst other operations. As a developer, you'll probably work with large amounts of data, and file handling makes that easier. This is why it's important to learn how to work with files. Whether you're working with data on your computer, on the web, or in the cloud, it will most likely be saved in some type of file. There are two file handling functions in Python: open and close. Let's explore the open function first. The open function is used for reading, writing, and creating files. The open function accepts two arguments. The first is the file name and/or the file location, and the second argument is the mode. The mode indicates what action is required, such as reading, writing, or creating. It also specifies if you want the file output in text or binary format. Let's explore the modes of file handling you can use in Python. First, you have R, which is used to open and read a file in text format, and RB opens and reads a file in binary format. You'll learn more about this later. R+, on the other hand, opens the file for both reading and writing, and W opens the file for writing. Note that W will overwrite the existing file. Lastly, A opens files for editing or appending data. Next, there's the close function. The close function is used for closing the open file connection. Note that it does not take any arguments. There is one more way to open and close a file in Python, and that's with the withOpen function. The advantage of using it is that it closes the file automatically. The withOpen function will be demonstrated shortly. By now, you understand how to open files for certain actions, but you might be wondering what the difference is between opening a file in text and binary format. In Python, you generally handle files in two ways, either in text or binary format. The text format is more user-friendly because humans can read it. You'll not be able to read files in binary format, but they are much more compact and therefore result in better performance. Now let's cover how to specify the type of file handling in Python. Python uses text as the default format for file handling, so just passing in any mode for reading or writing a file will automatically set it to a text format. To set the file handling to binary, you need to pass the letter B along with either the read or write option. For example, you write open the file name and RB to read a file in binary format, or AB to append or add to a file in binary format. You'll now explore file handling in code. First, I declare a simple variable called file and assign the open function to it to gain access to a file. But before I can use the open function, I first need to create a new file for testing. Let's call it test.txt. Inside this text file, I add a simple line of text. Hello there. Good. Let's go back to the Python file. Inside the parentheses of the open function, I can now add the first argument, namely test.txt between quotation marks, since it's a string. For the second argument, I type in the word mode, $, and then I will just use R for read, also between quotation marks. So far, the variable called file will have access to the contents of the test.txt. But to actually read the file, you need to add a readline or readlines function. Readline will just return the first line of the file, while readlines will output an array with multiple lines. Since we only have a single line of text in this file, I'll just use the readline function. I type file.readline and parentheses. I assign the line of code to a new variable named data. Then I add a print statement to print the contents of data. Lastly, I add a close function that will close access to the last text.txt file. I simply close with a set of parentheses. I click on Run, and the content of the file is printed out, namely, hello there. Next, I'll demonstrate another way to gain access to a file in Python. I'll change the open function to the withOpen function. I'll just clear the screen. To assign a variable to the withOpen function, you need to add as after the parentheses and then the variable name. Why would you use the withOpen function? The withOpen function is better at exception handling and will automatically close the file for you. Just like before, I create a second variable data, readline, and then print the content of data. I'll click on Run, and just like before, the contents of the file are printed. You've covered how to work with files in Python. This includes the built-in functions to create and manipulate files, and the functions to open, read, and write files.
In this video, you will learn how to create files in Python and explore methods of inserting content into a new file. Files are used to permanently store data. Anything stored in the variables of your code exists in random access memory, or RAM. Since RAM loses its data when the computer is turned off, it's important to be able to create files so data is available for future use or as a permanent record. In Python, we can create new files using the open function and enabling the write mode. Let's start with a short example. I'll use a with statement with the open function and pass in the following parameters. Our file will be new file.text, and we'll set the mode by passing mode equals w. Now I assign this file to a variable by typing as file. A shorthand way to assign the mode is to enter a single character that represents the mode you need. In this case, I can replace mode equal to w with just the letter w, and it means the same thing. Now that I have access to the newly created file as a variable, I can begin to add content to the file using the write function. On a new line, I type file.write, and I'm going to add some simple text. This is a new file created. When I click Run, the Explorer pane on the left-hand side of VS Code displays that my file, called newFile.txt, has been generated as a new file. Clicking once on the new file to select it displays its content and confirms that the text I pushed through using the write function is now present in the file. If I choose to write multiple lines of content to the file instead of a single line, I can use the writeLines function. The writeLines function accepts a list. A list in Python is represented by square brackets and then a comma for each line. I edit my file.write to say file.writeLines. Then, within square brackets, I add a comma after the sentence and type the next sentence. This is another line to be added. I click on Run, and the new file.txt now has the two lines created by my writeLines function. But it's not exactly the way I need it to be. Python will add the contents of the list exactly as it's specified within the list. If I want the content to break on a new line, I need to specify a new line by putting in a backslash and the letter N, no space. So, just inside the open quote of the second sentence, I add \n. Now, when I click on Run, the content of newFile.txt is more readable with each sentence on a separate line. One thing to note is that every time I run my script, it's replacing the current file. For example, if I insert the number 2 into the first line of text, click on Run, then check my text file, that has now replaced the previous file with one where I just added the number 2 in the first sentence, thus overriding the existing file with a fresh new file.txt. On the other hand, if I want to add to the file as opposed to replacing it each time, I just need to change the action of mode. To do so, I replace the letter W and put in a letter A, which stands for append. Now I click on Run 3 times, then I check my new file.txt to find that the contents have been added. It now has multiple lines. However, it has not pulled in exactly the way I wanted it to be. And the reason for that is I don't have a new line specified at the very beginning. So I add a \n before my first sentence. Since I need to replace the file, I change the mode back to W to ensure I am overwriting the last file. I click on Run, and that replaces the existing lines that were there. Now I want to add to the file again, so I change the mode back to append by changing the W to an A, and I click Run 3 times. I check the file and confirm that the new lines were appended each time. The final part of my code will be to trap exceptions. Always keep in mind the necessity to deal with any exception by using the try and except statements. I add a new line above my existing code, and there I type try : As an example, I use file not found error, which is an error that occurs often. This needs 2 new lines added to the end of my code, so I type except file not found error as E and press enter for a new line. Then, to print out the error, I type print error, E. Now, to force the error to happen, let's say I ask for a directory that I know doesn't exist in my current directory. So, the faulty directory is called sample. I edit my code to read sample/new file.txt. Now, I'll clear my terminal and run my screen again. I get the error generated by my print command, no such file or directory. So, take care when you are creating files that the directory where you want to place the file actually does exist. In cases like that, you must ensure the directory already exists, or create a directory from within Python and then create the file inside it. In this video, you learned about creating files within Python using the append and write modes and inserting single or multi-line content into the file.
You've reached the end of this module on basic programming with Python. During this module, you've received an introduction to Python functions and data structures, and explored how Python deals with errors, exceptions, and file handling. Now it's time to recap the key points of this module. As with most programming languages, functions are the basis for creating actions in Python, and by completing the first lesson in this module, you should now be able to declare a function in Python, pass data into a function, return data from a function, and explain scoping at a basic level. In order to use functions efficiently across a project, it's important to determine their accessibility across different levels of code. In this lesson, you also learned how to identify the 4 scopes, describe how functions control scope at different levels, explain data structures, and describe the concept of lists in Python. Python has several built-in data structures to help you to organize and store your data for easy access, and you've learned about the most common ones. On successfully completing the second lesson, you should now be able to identify list methods, explain what types can be stored in a list, describe how to iterate over a list, and explain the main uses of tuples, sets, dictionaries, and quargs. Python file handling and exceptions were topics in the final lesson in this module. Having completed this lesson, you should be able to identify how to create and manipulate files with the open function, describe how to read files in Python, and demonstrate how to output different formats and store file contents in data structures. This module gave you the opportunity to get started with basic Python programming. Well done. That's one more step towards becoming a Python developer. Developers can structure their code in many different ways. Python allows for object-oriented, procedural, and functional programming models, or as they are often called, paradigms. In this video, I'll focus on procedural programming, which is like writing step-by-step instructions that a program executes. It's an important stepping stone to object-oriented programming. Therefore, as a new developer, it's important to learn more about it. The main purpose of a programming model is to structure your code. That structure makes it easier to update the code and create new functionality within the code. But there's no one perfect model that's a solution to coding structures, and sometimes a combination of approaches works best. Procedural programming structures code into procedures, sometimes called subroutines or functional sections of code. Because of this approach, the code is made up of logical steps to complete a specific task. For example, adding two numbers to return their sum. I can add together the numbers 5 and 10 with a short piece of code. Now I want to add together the numbers 8 and 4. However, the code I wrote was specifically to add 5 and 10. For my new numbers, I must create another similar piece of code to do the calculation. That would not be a very efficient way to code. Instead, I change the code into a function that will accept two numbers as arguments and return the sum. With this function, I don't declare the actual numbers as variables. Instead, I use the parameters a and b. Less code is needed. But something more important has happened. I now have the function called sum, which can be reused as many times as I like, with many different sets of numbers. In programming, there is a principle called DRY, don't repeat yourself, and it's all about reducing duplication in code. The original code I wrote to add two numbers together to return their sum is a good example of what not to do, because I had to write the code twice to accommodate the second set of numbers. A guideline to keep in mind is to create functions that can be reused throughout your application. Let's examine another example, this time for calculating the total of a bill and adding tax to it. The code will be presented in 4 sections to help you focus on what each procedure does. First, the bill total function accepts a bill as a parameter and loops through it to calculate the total bill and return its total. The calculate tax function accepts 2 parameters, the percentage and the bill total. Then it returns the total amount of tax to be added to the bill, which is also rounded off to 2 decimal places. The food bill, which contains its items, represents a customer's bill which is static, but could also be changed to an input to accept data from the user to dynamically create a bill. The last few sections will call the 2 functions to calculate the bill and tax, and then print each out along with the overall total. Could you identify the subroutines or functional sections of the code? And did you note how these sections reuse one another? Now let's put the 4 subroutines together to examine the 4 ways in which the footprint of the code is reduced by procedural programming. It's best to inspect the code by starting at the end. Tax total reuses food total. Food total reuses bill total and food bill. Calculate tax reuses bill total. And bill total reuses food bill. In summary, the advantages of the procedural paradigm are: it's easy for beginners to learn and get started. Procedures can be reused by other parts of the code. Code is easy to understand because each procedure is broken into specific tasks. Procedural programming does have some disadvantages, including it can be harder to maintain and extend. In some cases, it doesn't relate well to real-world objects. Data is exposed throughout the whole program. Procedural programming has both its advantages and disadvantages. As you learn more as a new developer, you will be better able to decide if it's the best approach to a specific piece of coding or not. In this video, you'll learn about algorithms. An algorithm is a series of steps to complete a given task or solve a problem. On a day-to-day basis, you use algorithms all the time to complete tasks. One such example is following a recipe to make an egg omelette. First, you have the list of ingredients to use in your omelette. This can be called your input. Next is the method or the instructions to follow step by step to create your dish. Finally, you complete the omelette, your output. The steps to make the omelette are the same every time. An algorithm in programming works in a similar way. In programming, algorithms are used to solve a multitude of problems that range from simple to very complex. The key to understanding and creating an algorithm is to break the problem into smaller parts, just like the egg omelette recipe. That way, you build up the steps to complete the algorithm that will resolve the overall problem. Now, let's explore a practical application of algorithms in coding. I'm going to demonstrate a particular algorithm that checks if a word is a palindrome. A palindrome is a word that can be spelled the same both backwards and forwards. For example, the word race car is a palindrome because I can spell it forward as R-A-C-E-C-A-R, and backwards it's still the same, R-A-C-E-C-A-R. To be able to check if a word is a palindrome, I need to use an algorithm. As mentioned earlier, an algorithm is a series of steps to solve a problem. Let me break down the problem. I know the string in my example race car has an index, and I need to check if the index at the front of the string is equal to the index at the end of the string. In this way, I can compare the two values at the indexes. So I print str0 because that's the first index, and I also print str6 because that's the last index. I can just count that up to double check. 0, 1, 2, 3, 4, 5, and 6. And then I click on Run. The output is the two values I need to compare, both of which are the letter R, at the beginning and at the end of race car. Now I'm going to break down our problem into smaller steps. First, I need to check if the value of index 0 is equal to the value of the last index 6, which in this case is R. Then I need to check that the next or second character, which is index 1, is equal to the second last character, which is index 5. Finally, I need to check if character 2 is equal to character 4. What I need to do is to check if these conditions are true or false. So let's check how I can write this out in some code. I begin by creating a function def is palindrome, and I know that it will accept a single parameter called string, which I've entered. Now I want to get the starting index as well as the end index. I put the start index into a variable that equals 0. Every string will always start at the index 0, and then the end index is going to be the length of the string. So I enter end index equals len function, str, and then -1. This is because a string always starts at 0, and I have to think about the last index. Next, what I want to do is iterate through the string itself and compare the starting index with the end index characters to validate that they are the same. To do this, I create a for loop by typing for x in str, and I'll make the comparison within the for loop. I can check if the first index is equal to the last index, and since the two characters R and R are the same, it'll continue to be true. But it would be quicker for me to check if it's false because then I'll know straight away if it's not a palindrome. So I do an if statement and I use the string being passed in as the parameter. Then I use the start index to get the character, and then I check if it's not equal to the string within the end index. If this condition is met, it will return false, which confirms that it's not a palindrome. But if the condition is never met outside the for loop, then it returns true, which confirms that it's a palindrome. I've done all the checks across the starting index and the end index, and it returns back to the condition of true to confirm that it's a palindrome. Now I'm going to test the algorithm to verify that it works. I use a print statement. I call the isPalindrome function, and I pass in race car because I know that it's a palindrome. I click on run and it returns the value of true. If I change race car to race cars and I run it again, the condition of false is returned. This is an example of creating an algorithm in code to solve a problem. It has a series of steps that have to be followed to resolve the problem in code to give back the condition of is the string a palindrome or not. Now you know how useful algorithms can be as a step-by-step way to solve a problem with coding. An algorithm can be used to solve problems whether small or complex. Once the steps of an algorithm are created, they will then execute the same way each time the algorithm is used. Perhaps you've heard of functional programming. It uses a different paradigm than other models such as object-oriented. It's particularly adept at processing large amounts of data at high speeds. This video will get you started with what functional programming is. Later in the lesson, you'll explore topics such as pure functions, recursion, reversing a string, and useful Python functions such as map and filter. Let's start by exploring the role of a function. Functions take some input, process it, and then produce some output. There are two types of functions, traditional and pure. Pure functions will always do the same thing and return the same result, no matter how many times they are called. There are several differences between traditional and pure, so let's list them. Traditional functions can access and modify variables on the global state, but pure functions cannot. Both traditional functions and pure functions can access variables in the local state. Traditional functions can change args, whereas pure functions cannot. And lastly, the output of traditional functions does not depend on input. However, the output of pure functions does depend on input. Functional programming, in essence, is a programming paradigm that utilizes functions for clean, consistent, and maintainable code. Compared to object-oriented programming, which we'll learn about later, functional programming differs by design. Functional programming does not change the data outside the scope of the function. This simply means that the function should avoid modifying the input data or arguments being passed. Instead, it should only return the completed result of the intended function being called. Functions are considered standalone or independent, and this aids the clean and elegant nature of the code. In fact, many of the strongly typed object-oriented languages have incorporated functional programming into their structure. In order to support functional programming, the language itself needs to allow functions to be passed as an argument and also return a function to its caller. In Python, functions are what is known as first-class citizens, which essentially means they have the same level of strings and numbers. They can be assigned to a variable, passed as an argument, or returned to its caller. Let's explore a few examples of functions available in Python. Take, for instance, the sorted function. The sorted function accepts a list of items and then returns that list in a sorted order. You can use a sorted function to list items in alphabetical order. By passing a list of coffees to the sorted function, the return sorts the list in alphabetical order. The great thing about functional programming is that the logic behind certain tasks is already built in for you. Functions are reusable and thus save a lot of development time. But did you know that you can also create your own functions specific to your own requirements? Let's look at a simple example. Imagine you want to spell the names of the coffees backwards. This might not be entirely useful, but it's a good showcase of functional. You can create your own simple reverse function to do this. Define the function. Let's call it reverse and assign the variable str to it. Now return the value of str with a slice function. You'll learn more about the slice function later in the lesson. Then assign a variable to get the result to the map function. The map function accepts as its first argument the reverse function and then the iterable, coffees. It will then automatically handle the iterations to go through each coffee and apply the reverse function to it. In this video, you have learned what functional programming is, and you were introduced to examples of built-in functions in Python. A good coder will try to keep code clean, make it easier to debug, and ensure it's extendable. The great thing is that pure functions can help you do all that. In this video, you'll learn what pure functions are and how you can use them in functional programming. It's important to understand that there is a clear difference between traditional and pure functions. A pure function is a function that does not change or have any effect on a variable, data, list, or set beyond its own scope. For example, if you have a list with a global scope, a pure function cannot add something to that list or alter it in any way. Let's explore an example function and then determine if it is a pure function or not. This code includes a list on the global scale and a function called add to a single parameter called item. The value of item is then set to 4. The output is 1, 2, 3, 4. What do you think? Is this a pure function? No. It's not a pure function as it changes the global list by appending the item which is passed as an argument. In order to change it to a pure function, you need to think how to extend the function to accept a list as an argument, add the item to the list without modifying the original list, and how to return a new list with a newly added item. The solution is to create a new list and copy or clone the data from the original list. Let's revisit the code to make some changes. This time, you make a copy of the original list. The new item is added to the new list. Then the new list is returned to the caller. Now that you have a better idea of what a pure function is, let's review a few benefits of pure functions. Firstly, with pure functions, you always know what the outcome will be. Pure functions are consistent snippets of code that do exactly what they are intended to do. Thirdly, pure functions include the ability to cache since you know the return is always going to be the same. Lastly, pure functions lend themselves well to a multi-threaded program. In multi-threaded programs, more than one process could run concurrently, which creates many threads of data. Pure functions will help prevent changes on the global scope, ensuring data stays reliable. Now I think it's time to offer you a step-by-step demonstration in VS Code of how to alter a normal function to a pure function. Pure functions are especially useful because they are easier to read, better to debug, and more consistent. I'll now take you through a simple example to demonstrate how to create a pure function. I'll start by creating a function that does not behave like a pure function, and then I'll tweak it until it's a pure function. First, I create a list called myList, and inside it, I add 3 numbers, 1, 2, and 3. Then I add a simple function called addToList, which takes a single variable called item. This function will return my list and append the new item that is being passed through. Below that, I call the function addToList and assign the value of 4 to the variable item. Finally, I add a print statement of my list so that I can focus on the output in the console. I click on the Run button and the numbers 1, 2, 3, and 4 are printed out. This means that my list now contains the inserted number 4 as well, because the function appended it to the existing list. What do you think? Is this a pure function? No, it's not, because the data has been manipulated at the global scope from inside the scope of the function. Let's try to turn it into a pure function. The first thing I'm going to change is how the function is being called. I want to pass in a new argument. I type newList equals addToList. I keep the value of 4, and I'll also print out the new list below the first print statement to compare the output. Now let's make some modifications to the function itself. I add a simple append to myList, which is going to take in the item variable. I type myList.append and item in parentheses. Then I want to return back the list. I type return myList. Now I click on Run, and the output in the console indicates that both myList and newList include the values of 1 to 4. It's clear that the function is still not a pure function. Why? Because even though it's returning a new variable, it still has a reference to the myList variable. Let's try something else to turn it into a pure function. This time, I'll accept a parameter called lst for the variable item. I type lst, in front of item in the parentheses. I also change the append statement to lst.append item. And I also change the return action to return lst. Finally, I change the call action by passing in myList, inside the parentheses before the value of 4. Let's run that. And once again, both lists contain the values of 1 to 4. The reason for this is that the function is still using the list as an argument, and it's still being updated from within the function. So ultimately, in order to create a pure function, the problem that I have to solve is how to create a new list. And then I need to solve how to get all the values from the list that's being passed through and then return the new list back to the calling action. Let's give it another try. This time I create a new list by creating a copy. In the function, I type the name of the new list nl equals lst.copy and a set of parentheses. Now, instead of putting the passed values into the lst, I'll put it into the copy. So I type nl.append, and then I also change the return action to return nl. I clear the console screen so that I can focus on the output and click on Run. And finally, I get 2 different results. My list is printed with the values 1, 2, and 3, but the second print statement for newList includes the values of 1 to 4. This function is now a pure function because it adds a value to a list, but it doesn't manipulate the original list outside the function. In this demonstration, you've learned what a pure function is and what you need to do to change a function that's affecting a list on the global scope to a pure function that does not interfere with the original list. It's likely that you'll use pure functions regularly in your programming career because pure functions will keep your code cleaner, easier to debug, and easier to extend. In programming, recursion is used for solving problems that can be broken down into smaller, repetitive problems. It's especially good for working on things that have many possible branches and are too complex for an iterative approach. One good example of this would be searching through a file system. So, what is recursion? Recursion is essentially a function that calls itself. Recursion creates a pattern of repeating itself over and over and over. So what does that mean from a coding perspective? In this example, a function accepts a single argument, and inside the function it has some logic to deal with the problem it's trying to solve. The key part is the return. In the code, the return statement is returning the same function. Recursion is quite similar to a for loop. It will iterate, or in the case of a recursive function, call itself multiple times. But a warning, when you create a recursive function, you must always consider the result. If you don't, it will spin into an infinite loop and suck up all the memory until the program eventually crashes or gets terminated. Let's compare how to use a looping and a recursive solution to find the factorial of a number that can be solved. Let's start with the looping solution. The looping function accepts a single integer called n as an argument and first checks if the number is less than 0. If it is, it returns 0 as you can't have a factorial negative number. The else condition sets the factorial to 1 and then loops through the range of the argument, which is 5 in this case. The loop will calculate 1 times 2 times 3 times 4 times 5, which will give the answer as 120, the factor of 5. Now let's explore the recursive solution to the same problem. The recursive function is simpler and more compact. The main reason for this is that you no longer need the for loop to do the iteration of the n argument. The first line of the function verifies that the number is 1 and returns 1 if true. The else condition multiplies the argument n by calling the find factorial recursive function and passing in n minus 1. Recursion can be difficult to understand. By way of explanation, let's demonstrate exactly what happened as the function calls itself. The function is being called over and over, and the part that changes is the value being passed into the function each time. The argument of n, or 5 in this case, is decreased by 1 each time until it finally is 1. This stops the function from being called again and exits out of the recursive process. So how exactly did this code get the result of 120? This is provided by the return statement. It keeps a reference to the incremented value, and this is the final return after it has been completed. Right, it's time to review the advantages and disadvantages of recursion. First, the advantages are recursive code can make your code neater and less bulky. Complex tasks can be broken down into easier to read subproblems. Generation of sequences can be easier to understand than nested loops. But there are disadvantages. It can be harder to follow the logic in recursive code. In terms of memory, they are expensive and sometimes inefficient. It can also be difficult to debug and step through the code. You should now be able to explain what recursion is and how it can be used to solve problems. I believe you'll benefit from using recursions in your code in the future.
One of the basic ways to test a Python developer's problem-solving skills is by asking them how they would reverse a string. Knowing how to do this is very useful in the production environment. Some programming languages have a built-in function to reverse a string. Python doesn't have such a function, but fortunately, due to the language's flexibility, there are several ways to do this. In this video, I will show you 2 ways to reverse a string in Python. First, I'll demonstrate how to do this with the slice function. To start off, I create a file called stringreversal.py. The format or syntax of a slice function is that it always starts with the name of a string, open square bracket, the start parameter, colon, the stop parameter, another colon, and then the step parameter, followed by a close square bracket. I'll add a hash symbol in front of this line to indicate that it is a note. This is called the extended slice syntax. The start and stop parameters are the indices between which the function manipulates the string. The step parameter is the hops or jumps the function makes while it traverses a given string. I will now first define a string, then manipulate the string with the slice function, and finally print the string. I'll call the string trial and assign the word reversal as its value by typing trial =, and the word reversal between double quotes. To manipulate the string, I create a new string called new trial. Now, I assign a value to new trial with the slice function. I type an =, trial, and open square bracket. To instruct Python to use the entire string, I leave the value of the start and stop parameters empty. I simply type 2 colons and then add the value of the step parameter as the number -1, followed by a closed square bracket. The negative value of the step parameter indicates that the string needs to be traversed from the right, one index position at a time, instead of the conventional method of starting from the left. Finally, I print the manipulated string to test if it works. I type print, and between parentheses, I add the string name new trial. I click on run. Great! In the terminal, the string has successfully been reversed. In summary, the entire string is traversed from right to left, one index position at a time. This new sliced object is then copied to another string, which is then rearranged and printed. It should be noted that you can use the slice function to manipulate the same variable. I only used a second variable in this example for clarity. The slice function is the simplest way to reverse a string. I will now demonstrate another way you can use the slice function to reverse a string, this time using recursion. I start by creating a new file and saving it as stringreversal2.py. Next, I define a function and pass a string variable to it, namely str. I type def and the function name string reverse and str between parentheses, followed by a colon. This function will act as a conditional if statement. I type if len open parenthesis str close parenthesis 2 equal signs, the number 0 followed by a colon. On the next line, I'll return the value of str. Now let's add the else statement. The else statement will recursively call the slice function, but with a modified string every time. On the next line, I add else and a colon. Then, on the next line, I type return string reverse str. But before I close the parentheses, I add a slice function by typing open square bracket, the number 1, and a colon, followed by the closed square bracket. This time, the string is traversed from the front, skipping the first character in every loop. And this first character skipped is appended to the remaining string. So, I now add a plus sign, str, and the value 0 in between brackets. Outside the function, I give str the value of reversal. Then, I create a second variable that will store the value of the returned string. I'll call this variable reverse and assign to it the value of the function. Finally, I add a print statement for the variable reverse. Let's run the code. Success! The string displays in reversed order in the terminal. Essentially, the function calls itself by passing a different string in each recursion and appending the element it has kept right after it. In this video, you learned 2 different methods to reverse a string in Python. The first by just using a slice function, and the second by using a slice function with recursion. Let's say I want to generate a list using an existing list. The general process would involve applying some sort of operation to each element of the existing list, and using those outputs to generate the new list. There are many ways you could do this in Python. In this video, you will learn how to process a list with the map and filter functions. My file contains a list called menu, and it contains a list of various coffees. I want to filter this list for specific coffees. Say, I want to print all coffees that start with the letter C. I will do this by creating a function through which I will pass the list to compare it to the letter C. Then, I will demonstrate how to get the output, first as a map, and then as a filter. Before I start, let me talk you through the format of a map function, but keep in mind, the filter function follows the same format. To create a map, I type map, and then need to define its arguments. The map function accepts 2 arguments. The first argument is an actual function. In this case, it will be the function that I will use to match values based on a condition. The second argument is the articles that will be passed through that function. In this case, the coffees from my menu list. Now, let's create the function with the condition. I press enter twice to move the map function down. I type def and the name of the function, which is find coffee. I then add a single parameter coffee between the parentheses and a colon after the closed parenthesis. The coffee parameter I added will be the coffee from my list. I now need to check if the first character of the items in the list matches the letter C. To do this, I will create an if statement by typing if coffee and pass in 0 to set the action on the first letter of the coffee variable. I then type the equal sign twice, followed by the letter C and a colon. I press enter, and on the next line, I type return coffee if the statement is true. To use the map function, I'm going to assign it to a variable called map coffee. I follow that by entering an equal sign and the map. Now I can pass in the arguments for the map function. Remember, the first argument is the function itself. I enter the function name findCoffee. It is important to note that I am not calling the function. I'm just passing it in like an argument. I add a comma after findCoffee, and then the second argument, the article, in this case, menu. Finally, I want to print out the value of map coffee so you can focus on the results in the terminal. I click on run, and in the terminal, I receive a map object as output. The next step is to iterate through the map object. I type for x in map coffee, print out the value of x. I click on run again, and now I get the output as a map. In the terminal, a list appears with a lot of values that say none, except cappuccino and cortado. And that is because cappuccino and cortado are the two matches for the letter C in the function. The great thing about the map function is that I did not have to create a for loop to go through the list. The map function takes the function as an argument and passes the menu list values into the function one by one. So that handles the iteration for me, which makes it quite useful. Next, I'm going to demonstrate how to get the output with the filter function. To start, I'll comment out the section of the code related to the map function and clear my terminal. The filter function works much the same as the map function. I declare a variable called filterCoffee and assign the filter function to it. Again, I add the two arguments, namely the findCoffee function and menu. Then, I print out the variable filterCoffee. I click on run and receive a filter object as output. Now, I will iterate through the filter object just like I did with the map object. I type for x in filterCoffee, print out the value of x. I'll clear the terminal now and click run. This time, only cappuccino and cortado are returned. Why is that? Let me explain the difference between a map and a filter function. A map takes all objects in the list and allows you to apply a function to it. A filter also allows you to take in all objects in the list and runs through a function, but it creates a new list and only returns values where the evaluated function returns true. That is why there are no none values displayed in the output for the filter function. You now know how map and filter work in Python, and should be able to also explain the difference between the two functions.
Programming languages are built upon certain models to ensure that code behaves predictably. Python primarily follows what is known as an object-oriented paradigm or model. As you'll soon discover, object-oriented programming, or OOP, relies heavily on simplicity and reusability to improve workflow. By the end of this video, you'll be familiar with the object-oriented programming paradigm. You'll also be able to identify the four main concepts that define object-oriented programming. Programming paradigms are a strategy for reducing code complexity and determining the flow of execution. There are several different paradigms such as declarative, procedural, object-oriented, function, logic, event-driven, flow-driven, and more. These paradigms are not mutually exclusive, so programs and programming languages can opt for multiple paradigms. For example, Python is primarily object-oriented, but it's also procedural and functional. In simple terms, a paradigm can be defined as a style of writing or program. OOP is one of the most widely used paradigms today due to the growing popularity of languages that use it, such as Java, Python, C++, and more. But the OOP's ability to translate real-world problems into code is arguably the biggest factor in its success. OOP has high modularity, which makes code easier to understand, makes it reusable, adds layers of abstraction, and allows for code blocks to be moved between projects. To help you better understand OOP, I'll first clarify some of its key components, which are classes, objects, and methods. A class is a logical code block that contains attributes and behavior. In Python, a class is defined with a class keyword. The attributes can be variables, and the behavior can be functions inside of it. You can create instances from these classes, which are called objects. In other words, a class provides a blueprint for creating an object. In more practical terms, let's say you want to record the attributes of employees at Little Lemon, such as their position and employment status. You could create a class called employee and conveniently bundle those attributes in one place. Next, let's discuss objects. As mentioned, an object is an instance of a class, and you can create any number of them. The state of an object comprises its attributes and behavior, and each one has a unique identifier to distinguish it from other instances. The attributes and behavior of the class are what define the state of the object. For example, you can create the object emp1 by calling the employee class. Once called, you can define the position and employment status attributes as shift lead and full-time, respectively. In code, this would be written as emp1 equals employee, followed by shift lead and ft in parentheses. This is a case of instantiation or creating an instance of a class. Finally, there are methods, which are the functions defined inside a class that determine the behavior of an object instance. Let's say you want the employee object to output a string that states their position. You would first declare their function intro in the employee class, and then call it on an object to get the output. Now that you know about classes, objects, and methods, let's explore the concepts that OOP hinges upon. The first one is inheritance, which is the creation of a new class by deriving from an existing one. The original is called the parent or superclass, while any derivatives are referred to as the subclass or child class. The next concept is called polymorphism. It's a word that means having many forms. In the context of Python, polymorphism means that a single function can act differently depending on the object that calls it. For example, the built-in plus operator works differently for different data types. In the case of integer data types, the built-in plus operator performs addition operations such as 3 plus 5 equals 8. On the other hand, in the case of string data types, the built-in plus operator performs a concatenation or combining two strings together. This ability of modifying functionality is called polymorphism. The third concept is encapsulation. Broadly, this means that Python can bind methods and variables from direct access by wrapping them within a single unit of scope, such as a class. Encapsulation helps prevent unwanted modifications, in effect reducing the occurrence of errors in output. And finally, there is a concept of abstraction. This refers to the ability to hide implementation details to make data safer and more secure. Note that Python does not support abstraction directly and uses inheritance to achieve it. This is something that you'll explore in more detail later. There are some other important concepts in OOP, such as method overloading, method overriding, constructors, and more, which you'll learn about in more detail later. In this video, you became familiar with OOP paradigm and the four concepts that support it: inheritance, polymorphism, encapsulation, and abstraction. See you next time.
Code reusability is the use of existing code to build new software. Reusability is a core programming concept. By the end of this video, you'll not only be able to create a class and instantiate it with variables and methods, but you'll also discover how referencing the same variables and methods in separate instances can produce different outcomes, meaning that the code is reusable. I'll start by creating a new file called recipes.py, where I'll also create a class called recipe. Before continuing, let's also explore two special methods in Python. The first one is the new method, which is responsible for creating and returning a new empty object. To write it, I start with the def keyword, followed by _new. It then appears as a suggestion so I click on it to fill out the rest. The CLS here is not a keyword, but rather a convention. It acts as a placeholder for passing the class as its first argument, which will be used for creating the new empty object. The second method is the init method, which is similar to what is known as a constructor in some other programming languages. It takes the object created using the new method, along with other arguments, to initialize the new object being created. I write it with the def _init, and then choose the first suggestion that pops up. The init method takes the new object as its first argument. The self keyword here is another convention. It has no function itself, but serves as a placeholder for self-reference by the instance object. So let's delete the two example methods and then write some code that demonstrates how to use the state of the object to your advantage. I begin with an init method, which I then use to initialize a few values. I do this for the value dish by typing self.dish equals dish. I then do the same for the values items and time. Before moving forward, I want to check that the arguments in the initializer will match those of my instances. To do so, I add dish, items, and time after self. Imagine a real-world scenario where a restaurant chef wants information about the recipes they have been using. So, let's write a class that will help them with that. I have the variables dish, items, and time, in which items will hold the recipe ingredients. I now write a function to produce a string out of this information. I type def contents and then self in parentheses. On the next line, I write a print statement for the string the plus self.dish plus has plus self.items plus and takes plus self.time plus min to prepare. Here we'll use the backslash character to force a new line and continue the string on the following line. For this to print correctly, I need to convert the self.items and self.time references to strings by appending str at the beginning and encasing each reference in parentheses. Now that I have a class set up, let's use it to create a pizza instance. I write this as pizza equals recipe, opening parenthesis, the string pizza, comma, opening square bracket, cheese, comma, bread, comma, tomato, closing square bracket, comma, and 45 to represent the time, followed by the closing parenthesis. I also want a pasta object, so let's copy and paste the code for the pizza object and change the object name to pasta, the ingredients to penne and sauce, and the preparation time to 55. Now that I have a class and two instances, let's see if I can access the instance attributes and methods. I write two print statements for pizza.items and pasta.items. When I run the code, I find that despite passing the same function and variable items, the two instances produce different contents. So next, let's try printing the instance method contents over pizza. Before we move forward, let's clear the terminal so we can more clearly see what the output will be. I type another print statement for pizza.contents and empty parentheses. I run the code once more, and the output uses the class method to print a line stating, the pizza has cheese, tomato, and bread, and takes 45 minutes to prepare. That's a demonstration of creating a class and instantiating it with variables and methods, then referencing the same variables and methods in separate instances to yield different outcomes.
Let's try to solve a problem that may occur for managers at a restaurant. Because the managers are busy running the restaurant, they have limited time to deal with the needs of employees. The current system for paying wages requires managers to update each other every time an employee requests payment. Because this is cumbersome, they would like to implement an automated approach. So what can be done? Fortunately, there's a way to reduce the number of steps using instances. By the end of this video, you'll be able to explain what instance variables and methods are. You'll also know how to use them to change the state of an instance object. So let's write some code to help those busy restaurant managers. Let's start a new file called paymentinfo.py. In this file, I'll create the class payslips and initialize three variables in it called name, pay status, and amount. I start by typing class payslips, and then on the next line, I call an init function with def_init, and then select the triggered suggestion. For the variables, I type each one in the format self.variable equals variable. Next, I'll create two functions, one to display the status of the payment and another to update the status. The first function is written as def_pay with self in parentheses, followed by self.payment equals yes on the next line. The second function is def_status and contains an if-else statement. If self.payment equals yes, return self.name plus is paid plus self.amount with str appended to the beginning. The second part of the statement is else, return self.name plus is not paid yet. Finally, let's create instances of this class for the employees. I'll call them Nathan and Roger. I type the first instance Nathan equals payslips, and in parentheses Nathan for name, no for payment, and 1000 for amount. For Roger, I copy and paste this instance and set the values to Roger, no, and 3000 respectively. I also need to make sure to pass these values inside the init method, so I type name, payment, and amount after self. Now I'm ready to call the instance method status to check the status of the payments. I write a print statement for Nathan.status parentheses and for Roger.status parentheses. When I run the code, the output all appears on one line, which is not very presentable. I add a new line character between the items in the print statement, which is \n. This time the output is much cleaner. The output states that neither Nathan nor Roger have been paid. But let's say that one manager decides to pay Nathan, so I'll use the pay function to update the status. Remember that the pay function is set up to update the value of the payment variable. I type Nathan.pay parentheses and then copy and paste the last print statement. Above this line, I type another print statement with the string after payment. I run the code once more, and it now tells me that Nathan was paid 1000, whereas Roger still has not been paid. That's a demonstration of instance methods in action. Now I'll describe the code to you in more detail. Now let's discuss what happened in that coding example in more detail. The two instance objects, which are Nathan and Roger, each have their own states. You may have noticed that when the instance method pay was called to change the state of Nathan, Roger was not affected. This is because the method inside the class is not affected. Rather, it provides a separate blueprint to each instance, which can then be updated for that instance only. In the coding example, I didn't print the variable values after calling the pay function, but if I did, it would show that the payment instance variable for Nathan changed from no to yes, while Roger remained no. Now let's imagine that this code is the basis for an online payment system. It would allow either manager to click on the paid button for an employee, which then updates that employee's status. No more back and forth calls. In this video, you learned how to use instance variables and methods to change the state of an instance object without affecting any other instances. When instantiating objects from a class, you may find that the class is missing some properties that you use frequently. In that case, you could decide to make a new class that replicates the first one, but also adds a few more properties. It would be cumbersome to write everything from scratch, but thanks to inheritance, you don't have to. By the end of this video, you'll become familiar with inheritance in terms of child classes being derived from a parent class. Inheritance is a core concept in object-oriented programming generally, and in particular in Python, and it's a major part of code reusability. You may know that everything in Python is an object, but let's explore that idea more closely. It specifically means that every class in Python inherits from a built-in base class called objects, which is found in built-ins.objects. In other words, a class declaration such as some class with empty parentheses implies some class with object as its argument. When speaking of class derivation, the originating class is known as the parent class, superclass, or base class. The class which inherits from it is the child class, subclass, or derived class. Any name pairing is acceptable, but the important thing to know is that the child class extends the attributes and behaviors of its parent class. This allows you to do two things. You can add new properties to the child class, and you can modify inherited properties in the child class without affecting the parent. So now let's explore an example of how this is done in Python. Here you have a parent class P, which holds the variable a with a value of 7. Then there is the empty child class C, in which class P is passed as an argument. And finally, a lowercase c represents an instance of child class capital C. If you write a print statement for c.a and run the code, the output is 7. So even though C itself is empty, it still holds the attribute inherited from P. Keep in mind that any changes in the parent class will also affect any child classes. Now that you have an idea of how inheritance works, let's explore an example that demonstrates the flexibility it provides. I begin by creating a new file called employment.py, and my first step is to create a parent class called employees, where I'll define two variables for first and last names. I do this by typing class employees colon and on a new line def double underscore init to trigger and select the init method suggestion. For the first variable, I type self.name equals name on a new line, and for the second, I advance another line and type self.last equals last. I then add name and last to the init argument on line 2 after the word self. Next, I'll create two child classes that both extend the employee class. The first one I create is supervisors, and to call the employees class, I type class supervisors open parenthesis employees close parenthesis and a colon. I then need to modify the init method of the supervisors class so that I can add another variable named password. Again, I trigger and select the init method, but this time it already includes the name and last variables. By calling the employees class, the super method has automatically been applied to access the variables there and initialize them within the supervisors class. I proceed with adding the third variable, password, inside of the init method. I then make it an instance variable with the line self.password equals password. Now I'll write another child class called chefs. Again, I extend the employees class by adding employees as a method inside this class. I want this one to contain a new function called leave request. So I type def leave request and then self and days as the variables in parentheses. The purpose of the leave request function is to return a line that specifies the number of days requested. To write this, I type return the string may I take a leave for plus str open parenthesis the word days close parenthesis plus another string days. Now that I have all the classes in place, I'll create a few instances from these classes, one for a supervisor and two others for chefs. First, I type Adrian equals supervisors, followed by the values Adrian and A in parentheses. I can then copy and paste this instance 2 more times to serve as a template for the chef's instances. The first chef is Emily and will hold the values Emily and E, while the second chef Juno has the values Juno and J. Finally, as an instance of the supervisors class, Adrian needs another value for the password variable, so I'll assign Apple here. Next, let's call the instance method over Emily and pass a value to it. She wants to request 3 days off, so I type print emily.leaveRequest and the number 3. I'm also going to add another print statement that will check the value of the instance variable over the supervisor Adrian. I type print adrian.password. The third print statement prints the value of Emily's name variable. Now I run the code and get the following outputs. The words, may I take leave for 3 days from the first print statement, the word apple from the second one, and the word Emily from the third print statement. Note that both the instance variables and methods inside the individual inherited classes are present along with the variables from the parent class. In this video, you've learned how inheritance in Python helps to make code reusable, organized, and less redundant. In this video, you'll learn about abstract classes and methods. If you have an abstract class, you can ensure the functionality of every class that is derived from it. For example, a vehicle could be an abstract class. You can't create a vehicle, but you can derive a car, a tractor, or a boat from a vehicle. The methods we put in the abstract class are guaranteed to be present in the derived class because they must be implemented. If a vehicle has a turn-on engine method, then we assure that any method calls to a derived class that is looking for turn-on engine will find it. This could be for reasons of interoperability, consistency, and avoiding code duplication in general. In object-oriented programming, the abstract class is a type of class for which you cannot create an instance. Python also does not support abstraction directly, so you need to import a module just to define an abstract class. Furthermore, methods in an abstract class need to be defined before they can be implemented. With all these limitations, one might wonder why you would use abstract classes at all. One of their key advantages is the ability to hide the details of implementation without sacrificing functionality. Implementation in abstract classes can be done in two ways. One is that as base abstract classes lack implementation of their own, their methods must be implemented by the derived class. Another possibility is that the super function can be used, but that's a topic for another time. For now, let's focus on the module for defining an abstract class. You may not be familiar with modules right now, but they will be covered in more detail later. For now, it's okay just to follow along. The module is known as the abstract base class, or ABC, and needs to be imported with some code. After that, you can create a class called SomeAbstractClass and pass in the ABC module so that it inherits that class. The next step is to import the abstract method decorator inside the same module. A decorator is a function that takes another function as its argument and gives a new function as its output. It's denoted by the @ sign. You may not be familiar with decorators, but for now, it's enough to know that decorators are like helper functions that add functionality to an already existing function. Finally, here you'll define an abstract method which cannot be called on an object of this class. You will be able to call this method over objects of classes that inherit from this class. Similarly, we can define abstract methods with the help of what we call an abstract method decorator, present inside the same module. Any given abstract class can consist of one or more abstract methods. However, a class that has abstract class as its parent cannot be instantiated unless you override all the abstract methods present in it first. With that in mind, imagine a scenario in which an employer wants to collect donations from employees for a charitable cause. With your newfound knowledge, let's write some code to make that possible. First, I import the ABC module and its abstract method. Then I create the employee abstract class that calls abstract method to define a method called donate. Note that there's no implementation for this method here. After that, I create the class donation, which derives from the abstract class. Note that this class also overrides the abstract method. I write an implementation for the donate function, which takes a user input, stores it in variable A, and returns it. Next, I create two employee instances called John and Peter and call the function over each of them. I also create a list amounts to which the returned values will be appended. Finally, I have a print statement for amount, which will give the value of the total donations from both employees. In this video, you learned about abstract classes and methods and how to implement them in your code. Well done! You've reached the end of this module on programming paradigms. In this module, you explored procedural programming, functional programming, and object-oriented programming. We started the module by saying that procedural programming is considered the easiest and a basic stepping stone to object-oriented programming, and the first choice for new developers. Next, you explored functional programming, which in essence is a programming paradigm that utilizes creating functions for clean, consistent, and maintainable code. Lastly, you learned that object-oriented programming is about creating objects that contain both data and methods. These concepts should now make sense to you. It's now time to recap the key lessons you learned and the skills that you gained. With that in mind, let's summarize the key points you learned in this module. You should now be able to describe the concept of procedural programming, describe what algorithms are and how they can be used to solve problems, identify how algorithmic complexity is calculated, and recognize how algorithmic complexity can help in improving performance. You should also be able to describe Big O notation, explain what functional programming is, explain how pure functions are used in functional programming, and explain recursion and how it can be used to solve problems. What you have learned, however, did not stop here. You should therefore also be able to use different methods to reverse a string in Python. Explain the difference between the map and filter functions. Explain object-oriented programming and the four concepts it is built upon, and describe the relationship between classes and instances in Python. Finally, having studied the remaining key points in this module, you should now be able to create classes, instantiate classes, access their variables and methods, and change the state of instance objects by using instance variables and methods. This module gave a comprehensive introduction to different programming paradigms in Python. This is essential knowledge that prepares you to be able to create even better programming code.